Okay, should be live. Please let me know in the chat. Please hit the like button. Really helps fuel the algorithm. We started before 10 p.m. Central, so that's a win. But I think it's going to be a great stream tonight. This is one that I've planned on doing for a while, and I, for some reason, kept pushing it back and doing a different stream. But like I said, please let me know in the live chat how the sound is. Let me just check myself because, okay, it seems good. But okay. But yeah, please let me know in the chat how the sound is, and we'll get started. Hi, looking and sounding great. Thank you to my wonderful wife. So tonight's stream is one that I wanted to do for quite a while. It is a discussion that Alex O'Connor had back in September of 2025 with Jim. I'm not even going to try and say his last name. Maybe we'll just listen to it here. Jim. I can't even. Oh, it's because it's at 2.5 speed. Okay, let's try it again. Let's listen to how Alex says it because I don't want to botch his name.
Jim Al-Khalili, welcome.
Al-Khalili. Jim Al-Khalili. Okay. So, Jim is a theoretical physicist and science popularizer, is how he's described in the description to the video of the video that we're going to be going over, which is the full discussion is linked below. Highly suggest watching it. Like always, Alex is someone whose talks we've been looking at quite a bit lately, and more. I think he's one of the most talented and skilled thinkers in public discussion right now. And he described in this talk, even he described his kind of investigation and discussions into physics as an audit of the field of physics. And I thought that was the most perfect way of describing what he's doing and what really should everybody's kind of doing. But I think Alex is doing a better job of it than almost anyone else, especially physicists themselves. And yeah, they're failing the audit for sure. And I think a lot of his discussions show that. We've covered a few others that I think show that, and we're going to look at this one. But they discuss the nature of time. They discuss the definition of emergence. They discuss the weirdness of quantum mechanics and the potential issues involved with the various interpretations and why there isn't a consensus or a real, I guess, kind of concretized, confident interpretation of quantum mechanics that has, taken hold in the field of physics. And also, we are going to discuss kind of why I think that there is actually an interpretation of, maybe not an interpretation, but there is an anti-ideology for sure that has definitely taken hold in physics, and we will show some examples of it in their discussion. And yeah, with that, I want to try and keep this one a bit shorter because I've been doing some real long ones lately, and we are getting started late. So, but like I said, please hit the like button. Please comment any questions you have in the live chat. Comment any questions you have down below in the comments if you're not watching this live, and subscribe if you haven't hit bell notification. We live stream every Thursday. I usually get started later than I want, but I am always here. Very, very consistently. So, and there's various links below to more information about the project that this channel focuses on, which is Sentient Singularity Theory, which is a metaphysical framework that gives context to our observations. Just say that. So here, let's get started. First clip.
You spoke about the famous double slit experiment, this strange quantum phenomenon whereby where something sort of appears to act as a wave and a particle at the same time. And you issued a challenge. You said, now, if anybody thinks that they can offer a commonsensical explanation for this kind of thing, then do send me an email. How did that work out for you?
I wish I hadn't done that. I'd forgotten that I wasn't just talking to the 300 or 400 people in the audience at the Royal Institution, but obviously it gets recorded and goes out on their YouTube channel. To this day, I mean, that's about 10 years ago now. To this day, I receive on average 1 or 2 emails a week from people saying, I've solved the two slits mystery. Where's my Nobel Prize? Oh, no, we've tried that. There's a lot that's strange about quantum mechanics. Maybe we'll get into a few more of those things later on. But the great American physicist Richard Feynman said that the two-slit experiment is something. This is the central mystery of quantum mechanics. That we know that when you send light through to slits and you get interference patterns, light and dark fringes. What's weird is that sending particles, indeed even entire atoms through, you get the same wave-like behavior when you send particles through. So I went through in this lecture, how come? We understand quantum mechanics is this wonderful, powerful theory that has revolutionized the world, helped our understanding of the subatomic world, and yet at its heart there's this counterintuitive idea manifesting in this two-slit experiment that we still can't explain properly.
So quantum mechanics is stereotypically thought of as the sort of weird, spooky, kind of creepy, leaves room for new agers to get in and say there's all kinds of, this could explain telepathy and this and that. There was certainly a time when we start discovering these strange quantum phenomena and we think, this is completely inexplicable. It still has that reputation today, but it's been, 100 years. Is it still legitimate to say, as Richard Feynman also famously said, anyone who thinks they understand quantum mechanics doesn't understand quantum mechanics? Is it still true to say that it is just weird and creepy and spooky?
Not all physicists and indeed chemists who also use quantum mechanics would agree on this. I would say yes, it is as mysterious as it's ever been. The fact is, it's also been such a powerful mathematical theory. It's helped us invent all sorts of things, understanding semiconductors, developing.
Okay, so that's basically the general consensus, I think, of pretty much all of the physicists who are very public-facing, like Sean Carroll, like, Jim Al-Khalili. They might disagree with that, or maybe Sean Carroll would disagree with that. I don't think Jim Al-Khalili would disagree with his words here, but his own words. But the reality is that none of the interpretations that have been put forward, even by those who are confident in that they have kind of a solid enough understanding of explanation of why these certain observables are counterintuitive, none of their explanations have taken hold. And it's funny that Jim Al-Khalili said to the crowd, if you have a common sense explanation for making sense of wave particle duality and some of these odd, I guess, observables, like why you can't measure the position and the velocity of a particle at the same time. If you have a common sense explanation for this, email me and get a Nobel Prize or something like that. But that is any physicist who is accredited and speaks publicly, I honestly do, as much as even if I disagree with you and I think that you're like very, very lost, not all of them, but most of them, I really do feel for them, because I know they get so many emails of people that really struggle to explain even what their own thoughts on this are, and but are extremely passionate. And I can't judge those people. Somebody asked me on the last stream, what do you think of Terrence Howard? And I said, I think he's somebody who has gotten a glimpse of some things that are true and really struggles to find the right words to explain them in a way that is easily understood by the people who are listening. And I think that that's pretty much everyone in this space. Almost everybody. There's a few, very, very few. I would hope that I'm one of them. Please comment and let me know. But I wouldn't keep doing this if I didn't think that I had that I was good at it. But I think that's probably my biggest skill that's kind of unique is having the ability to describe in a much more coherent way some of these, I guess, some explanations for some of these phenomenon that are not accepted by the mainstream of physics, because none of them are, but they are put forward by at least me, and they line up with many other explanations that are put forward by other people, but very, very few people who are able to do this, and you could probably count them on your hands right now. But hopefully that increases, and I would say that it's not just people who lack accreditation. It's actually also people who have accreditation, and it's just that the people who are accredited have physics and mathematics degrees, upper graduate degrees in these fields. They don't realize, most of them do not realize the incoherence of many of the things that they're saying, and also they don't realize the fact just how much it matters, I think, that what they're saying isn't understood by the public, even if whether they understand it or not, think they understand it or not. And most of them, I would say, probably do think they understand it, but some of them acknowledge that they don't know. And they talk about here. Alex O'Connor mentions he's like, people in physicists will say this is what an electron is, and but what is it? And I think that's really what we need to get to the heart of, is diagnosing kind of at least the communication issue, and that memorizing descriptions that were put forward and by people in the past, like 100 years ago, like Alex O'Connor is saying, is not the same thing as explaining the nature of reality. It's just not. This has to be much more intuitive than it has been made out to be. And this phrase that Alex mentioned, I think Feynman said it, which kind of is really disappointing. I don't even know if he took it seriously, but let's look it up. If you think you understand quantum mechanics, you don't understand quantum mechanics. I hate this statement. I hate it. It is such a non-starter. It is a roadblock in and of itself, in the culture and the even the individual thinking of many people who are trying to, or who would want to see many of these things resolved. So think, understand quantum mechanics, don't. Okay. Famous phrase: if you think you understand quantum mechanics, you don't understand quantum mechanics, is a quote by the legendary physicist Richard Feynman. It means that while the math of quantum physics works to build amazing technology, the tiny quantum world goes against our everyday common sense, and we do not have a clear mental picture of why it happens. Somebody says, and I clicked on Reddit. I made a mistake. I shouldn't even click on Reddit. But just it was going into all these different people's opinions on this phrase. But I hate the phrase or the statement, and I've heard, I think before, if I remember correctly, that the context of it wasn't exactly what it seems, but I'm not sure. And whether or not that's true doesn't matter. The way that it's used today is basically it's a non-starter, and it is a mental roadblock in and of itself, and it is destructive to the culture of science and of physics, obviously, and so science in general, I think. But hello, uncertainty. It's not just a principle. Superposition, having it both ways. Yeah, but what is superposition? I understand what people say that the definition is. If you look it up, I know what it is, but I think that it is even assuming superposition to be actually true to what is occurring, I think is a misunderstanding. But we're going to get into this more. But first I want to talk about, and I've talked about this before a few times, but just speaking of a wave and or a particle's position and its velocity, not being able to, measure both of these things at the same time, you kind of have to pick one. This is another example that's given for kind of a spooky, odd phenomenon in phenomenon, I don't know, in quantum mechanics, and it's very much relevant, and it's kind of the same issue as what they were discussing earlier with the double slit experiment. But if you think about what a wave, I think all of this, let's back up. Almost all of the problem with that, with the interpretation, the confusion and the lack of consensus surrounding an explanation or interpretation of quantum observables has to do with definitional issues. It is a language problem mostly. It's also a metaphysics issue where there's certain assumptions made about the nature of reality or of existence itself, fundamental existence, that I think are handicapping. But even beyond that, there is definitely a definition problem. There is a language problem in physics, and it's gotten much worse, I think, than it was 50 to 100 years ago. And when many of these terms were created, I think they've lost their context. And that comes back to what I was saying about there's certain metaphysical assumptions about fundamental existence that are made by most physicists that I think are limiting. But regardless, when we're talking about a particle, what a particle is, it might be very, very much true, and I think it is, that the things that we call elementary particles in physics are very different in nature, actually, from our common sense and everyday conception and definition of what a particle is. Okay, like particles in the air, of dust, particles of sand, particles of wood, if you're cutting something or sanding something. Like this is our common sense conception of a particle, is that is a small piece of some material. And due to certain metaphysical assumptions about fundamental existence that are made by most physicists about the fundamentality of materialism, whether I don't even like that term, but it does kind of limit your ability to conceptualize and realize this definition issue. But it and incorporate like a lot of the context necessary to understand what might be happening with these observables. But in sentient singularity theory, it's very hard. Let me back up again. It's very, very hard to make sense of nonsense. It's actually impossible. It's not very hard. It's impossible. And what is being said about many of these observables is nonsense. So trying to reconcile the statements that they make with what could actually be coherent is not actually usually possible. So I'm going to just back up and talk about sentient singularity theory a bit. Sentient singularity theory, which there's links below, but if you go to sentientsingularity.com and you go to writings, you can click on, this is sentientsingularity.com, but writings, you can click on that, and there's an abstract of the paper that I'm working on slowly that is basically an overview of sentient singularity theory. It's a proposal for a metaphysics framework that asserts that and describes that the totality of fundamental existence as an initial and all-encompassing singularity of sentience that is creating additional sentient singularities within itself. So sentient being, you are a sentient singularity. You're someone. Okay, so that's the context that of sentient singularity theory, very broad overview. If that's the case, then we have to take the mental structure of and I think there's really only one mental structure for all minds, of information processing into account when we are observing anything. And when we're observing fundamental existence, but where we're not observing something that's kind of, we're observing change or a property of fundamental existence that is not kind of an emergent and emergently defined structure. We're just trying to look as closely as we can at a single point. What happens is that it's not about size anymore. It's about how your mind organizes and information and processes information. So the constraint of focus itself will cause you to observe a point just because of the nature of information processing, is that it has to break things into discrete packages and then order them and in a certain way that we can get into later. But when you're looking at as close as you can, I guess you could say, or as fundamentally as you can at existence, even as physically, through an electron microscopes or whatever. Well, whether or not you can actually look at an electron is kind of tough to say. But I screwed up and I started speaking about this in the context of its current understanding, which doesn't make sense. This is a focus point. It is not a particle. That's what I'm saying. It's a point of focus that is caused by the constraint of your own mind. You're looking at a single point. And when you're doing that, there are certain constraints involved, and that emerge from it. And if we're thinking about looking at a wave, you're standing on the beach and you're looking at a wave in the ocean, and you're looking through a telescope that, let's just say, it focuses as far as you could possibly focus, as close as you could focus. It's interesting that both of those make sense, far and close. But as close, zooming in on the wave as close as you can, you will see a point because the lens is a circle, and you're just going to see like there's something in that's a circular. And if this wave is moving and you ask a question like, what is the position of the point that we're looking at of this wave, which in physics right now, the common vernacular maybe is the right word, the common term to use for this is a particle or an elementary particle, like an electron or a neutrino or a quark even, but quark's a little different, is you're seeing a single bit of information, a point on this wave, and we're calling it a particle, but it's really a point of focus. And if you're asking where is this point of focus right now, which really you're asking where is the wave right now at the moment of observation, you're framing it as a static structure because you're assuming that it has a position that is fixed to that moment that you are making the observation. That will give you a position. But if you then ask what is its velocity also, you will not be able to get it because you've already made the assumption that it's a static structure. In the question, what is its position? Okay? Something that has a position that is something that has a fixed position. At least that doesn't mean it doesn't move after that. It just means it has a fixed position in the moment of asking the question. And if you have made that assumption, you cannot also ask what its velocity is, because velocity is assuming that it's moving, not that it's fixed. And so This is actually I struggled a little bit with kind of explaining this. Let me know in the live chat how I did. Hopefully you stuck it out through the entire way of me stuttering. But this, I believe, is a very actually sensible and easily understood and kind of intuitive explanation for why you can't get the measure the velocity and the position of a particle at the same time. And it's this issue is multifaceted. It's that the way that you're thinking of particle is framing how you're even asking and thinking about what results. It's framing your expectations of what you should be able to observe. And then I think it's misframing it as well. And then you are asking a certain question. It doesn't matter if you ask what is its velocity or first, or what is its position first. Either way, if you're trying to ask them simultaneously, really, which is the big mystery, is you can't measure a particle's velocity and its position at the same time. This is, I don't know why you think that you would be able to. That's my question. The mystery for me is why you think that those two questions even have the same context, really. I'm very confused. I think that it's very intuitive and obvious why you can't measure those two things at the same time. But it's also, maybe that's because I have this conception of the part of what an elementary particle is, that is a point of focus, of our focus. It is the point of our focus of an observation of kind of fundamental movement of the universe. Not of a structure in the universe, but of the universe itself moving. Kind of like as a wave. And the wave of the universe moving. I don't understand why this is difficult. I do understand why it's difficult for me to describe it sometimes, because even watching this and responding to it, it's kind of boxing you into certain definitions, and by the way that they use certain terms and things like that just actually don't make sense. And that's why it's confusing. If you can't make sense of something and it seems so mysterious and doesn't seem to be able to be logically reconcilable, it usually means that you have a definition problem. You have a language problem, and that you need to rethink whether or not you actually are defining everything properly. And so, if we're going to get to time in a little bit, and they talk about trying to reconcile time in the different contexts of physics, quantum mechanics versus thermodynamics versus general relativity, and they don't realize that they're using this one word, time, in all these different circumstances, but they're actually different. They should be different terms for what they're trying to understand. And then if there are three different terms instead of one term, then you wouldn't be struggling to reconcile them, because you wouldn't need to. And so there's a huge issue with that. The arrow of time versus the feeling of time versus time in as a moment in that can be kind of modeled by an equation in quantum mechanics. These are three very different things, actually. They're not one thing, but using the same term for all three circumstances is going to lead to you being confused. It doesn't make sense for us to not be able to define our terms. If anybody's like, we don't really know what intelligence is, we don't really know what consciousness is, it's such a mystery, we don't really know what entanglement is, or emergence is, or matter is, that means that you have a language problem, because these terms do not they're not even generated if there's confusion around what they mean. They are generated via an etymological blockchain that has the meaning of the term built into it, and the meaning of the term understood, and the necessity of the term understood in its own in its creation initially, intrinsically. So when anybody's like, we don't understand what intelligence is, it's like, no. We look at the etymology of the term, of the word intelligence. That's the definition. Now you need to figure out what you're trying to talk about, and maybe there isn't a term for what you're trying to describe, but like, to say that we don't know what intelligence is logically incoherent. And part of the problem is that many physicists and mathematicians and chemists and biologists and linguists and everyone in the world of accredited academia today has such a hyper specialization in that they're not able to look at this stuff more holistically. They just hear the term singularity, and it's like, well, in physics, the singularity is either the center of a black hole, or it's the beginning of the Big Bang, and that these are placeholder terms in the first place. They're blanks, they're variables in algebra. That's what it is, just a placeholder term. But these placeholder terms are framing, even if they are meant to just be a placeholder. And that's why you have gone on to believe that singularity is defined. The definition of a singularity is that it's the center of a black hole, or it's the center of or the beginning of the Big Bang. But or even in mathematics, it's the moment in which your equation falls apart. Singularity means singular, something that has intrinsic oneness, and maybe also built into it is an active aspect of it, because arity, the suffix arity, meaning airy, meaning, or binary, combined to abstract noun suffixity. It means the number of inputs, arguments, or operands a function or operation takes. So that's what I meant. It's kind of like continuous. There's like a continuity of it. Arity is the number of arguments or operands a function or operation or relation takes. Maybe this is, maybe that's actually a different singularity etymology. Okay. Old French, meaning single or alone. But arity, end of term, meaning. Language of word. Suffix. Isn't a suffix that's like the ending of a term. Suffix turns the adjectival concept into a noun representing a state, condition, or quality. Okay, like that's what I'm looking for. Turns the adjectival. So the adjectival means relating to or functioning as an adjective. So kind of like the state of something into kind of a structure. So you're structuralizing the state of something, which makes perfect sense for the term singularity. That's why I use it in Sentient Singularity. I mean, you are a singular being. You're someone. That's why we say, I'm someone, you're someone. We don't just say you're someone. And what's interesting is even in Sentient Singularity theory, there's a, this assembly hierarchy of, the body of that you kind of are embodied in is built out of an assembly of beings that are from the level below. So a multicellular organism or an animal like you or me is someone. You are someone. I am someone, and we are stacked on top of an assembly of cells. And as cells are stacked on top of an assembly of compounds or molecules, and that is stacked on top of an assembly of atoms, and that is stacked on top of an assembly of hadrons. So there's always someone, and some is like the grouping together of multiplicity, and one is one. It's interesting. Obviously, it's spelled differently, but some, even SOME, is kind of multiple, means like multiple things. Someone. That's fascinating. That like sentient singularity theory's metaphysics framework is actually consistent. It seems coherent with the term someone, not just the one part of it, but also the some part of it. It's fascinating. Okay. You missed the wit. I missed the wit. What wit? Your wit or my wit? Someone else's wit. God bless you and the family, Tyler. Thank you. I appreciate that. My daughter hopefully stays asleep. She's been waking up and just calling she just picks mommy or daddy, or mama or dada, just depending on how, right now she's transitioning from saying mama and dada to mommy and daddy. I talked about names in the last stream, and kind of it's fascinating, how why that she would change, and when we change these terms, even these names we have for others, including our parents, and it's always there. You're changing your definition of them a little bit. So your relationship with them is when you switch from dada to daddy to dad. It's different. And if you start calling your father by his first name, it's also your relationship with him has changed. But yeah, it's the way that all of the terms that we use for things, including names, including labels, they are framing. And so when we say a particle, if you are going to ask, what is the definition of a particle? Like, what is a particle really? What is a wave? What is probability actually? Like, we don't really know what it is. We don't know if it's actually a fundamental, if quantum mechanics is fundamentally probabilistic on a physical level, whatever that would even mean, or whether or not probability is just a tool that we use to make predictions about this future state of a system when we don't have all the information that would be relevant to making to having a perfect understanding of the future state or current state of a given system. So probability, again, anybody that thinks that we don't know what probability even is, you can't do that. You can't do that. You cannot change the definition of a word the way that we just do now. Hold on one second. Getting calls from my family, and I just need to make sure that I don't need to go. I've had 2 people call me from my family since I've started the stream, and I need to make sure there isn't some type of family emergency that I need to end the stream about. But it's a lot going on in my life. Good things, but that I will talk more about later, but not tonight. So I will say, for one, my brother had his wife had their first baby earlier this week, and mazel tov to them. That's amazing. Very cute. Very cute baby. Some babies are not so cute, and that one's a cute one. But yeah. Here. This is what I'm talking about.
Do you think science can answer that question fundamentally? Like what stuff actually is? Because the reason I ask is because, if I were to ask what a table is, you might tell me this table is made out of wood, and if I ask you what wood's made out of, and so on and so forth, we get down to an atom's made out of an electron. Well, what's an electron? And at this point, a lot of philosophers of science will say that the only answer is something like, well, an electron is a negatively charged particle. Well, what does that mean? Oh, it means it acts in this way, it repels other negative.
Yes.
But that's not what it is, that's what it does. And so at a fundamental level, especially in the quantum realm, where we're dealing with what are, hopefully, or if they're not, hopefully we'll find at some point, atoms in the true sense of being atomic, like fundamental particles. And we're asking what those things are, not what they do, not how they behave, or how they relate to each other, what they are. Do you think that is a question for the physicist?
I think it is, and I think they should try. It may be that we're peeling back layers of the onion, but it's also true that there are different scales at which certain explanations are sufficient. I don't need to understand the workings of the standard model of particle physics to work out how a washing machine works. At the level of table, it's made of wood, and wood has this property. That may be enough for my explanatory satisfaction. But I can go deeper, and I can talk about it being made of atoms, and atoms being made of smaller particles. And it may well be that there's more to come. But I think had physicists said, no, it's enough to know that a table is made of wood, we wouldn't understand then the nature of atoms. We have tried to go deeper, and very often we have arrived at what objective reality is at a deeper scale. That may not be the end point. Of course, there may not be an end point. We may never reach it. We may not be able to. But there is a truth about the true nature of reality. There's another concern that people have about, well, all we are ever doing is perceiving the world, and so building models in our heads. That's epistemology rather than ontology. But there is a real world out there, and I think the job of physicists is to get as close as possible to that objective truth.
We'll go back to the show in just a moment.
So, okay, I actually agree with this. I think that if you're a theoretical physicist, what a theoretical physicist really is they are a philosopher. That's what they are. That's it. You cannot be a theoretical physicist and not be a philosopher. Philosopher is a theoretical physicist is a philosopher. I'm not going to say all philosophers are theoretical physicists, but all theoretical physicists that are truly theoretical physicists are philosophers. And the most fundamental kind of branch of philosophy is metaphysics. It's assumed to be metaphysics, at least usually, if you ask people, and that has to do with the fundamental nature of things and beings, which are really two different things. So in sentient singularity theory, there are beings and there are things, and things are emergent. They are emergent constructions, emergent observations. Emergent definitions. You don't get to choose what you call something. Even an automobile, that is not a word that was chosen. It is a word that emerges, and because auto has a meaning and mobile has a meaning, it means automatic movement, basically, to be mobile automatically. And so there's the plane. We call things planes. It's like plane is shorthand for aeroplane, and the aeroplane is a craft that moves through the air on a plane. So just in how it kind of interacts even with the air, is that it's assuming it's always kind of moving on a plane. It's not just going like a drone or something like that. It's moving on a plane because it's moving in a direction always. So these terms were not chosen, and so they are emergent. But beings are fundamental in sentient singularity theory, and beings are someone. A being is someone. A thing is not someone. Or you could either say that, or you could say that beings, that there are things, and that some things are beings and some things are not, are just things and not beings. I don't really like this way of doing it, even though it still maintains coherence. In sentient singularity theory, there's always 2 degrees of freedom in terms of how you can preserve coherence in how you define things, but and more than just defining things, but in at least in also how you define things. There's fundamentally only 2 degrees of freedom in every circumstance, because when you make a choice, you're really choosing between what is one. You're making it's you can only really choose to do one thing or not do something, and you're not choosing to do that instead of this. You're choosing to do that or not do it, is really. And if I asked you, like, do you want to go to Jersey Mike's or to Whataburger, okay, or In-N-Out, if that's more your thing, you're not actually choosing between choosing to go to either Jersey Mike's or In-N-Out, really. What you're choosing to do when you finally do, let's say I choose Jersey Mike's, or I want Jersey Mike's. I'm choosing to go to Jersey Mike's instead of not going to Jersey Mike's. And if you're really getting fundamental with it. So because of this, it actually always creates a binary, because there's always this singularity of action that can be taken, and the choice is whether or not to take it or not. That creates this binary constraint that we have to deal with, and it manifests everywhere in all of our sense making, our decision making, our understanding, our differentiation is probably the first action within information processing. Is you make an observation, other than an observation. So you make an observation, and then that information is put into your mind, and it goes through certain process of ordering that organizes it into certain symmetry structures. And so the first one is differentiation. That's a binary symmetry structure. And then the second one would be categorization, probably. And then the third one would be hierarchization, so prioritization. And it kind of loops back in on itself again after that, because prioritization and it's very linked to differentiation. It's framing of differentiation in some ways, because it's built into your goals, and goals are kind of how everything is. All information is contextualized within the context of your goal. So anybody that says, "Oh, I'm just observing things and I don't have a goal," that's not possible. And that doesn't mean you have an agenda traditionally, like a traditional agenda, or a desire to use this, the things that you're observing in kind of an active way, but you're definitely always have a goal every time you take any action, including making an observation. But this process that your mind goes through is responsible for so many observations in quantum mechanics, and including triality in quantum mechanics, the triality or generationality of fundamental elementary particles, electrons, muons and taus, electron neutrinos, muon neutrinos, tau neutrinos, up quarks, charm quarks, and truth quarks or top quarks, down quarks, strange quarks, and bottom or beauty quarks. These are all, if you look at the standard model, every particle, every elementary particle is split into a binary. So you have the quarks, in which case you have what I call the masculine quarks, which is the up quark, and charm and truth or top quark, and then you have the feminine, what I call the feminine quarks, which is the bottom or the down bottom or beauty, and the strange quark. So there's two different words for the last in the series. It's in the feminine quarks, it's bottom or beauty, and in the masculine quarks, it's top or truth. But the middle one is for masculine quarks is the charm quark, and the middle one for the at least in the way the standard model is organized, on a poster, the middle one in the feminine quarks is the strange quark. So the first one is for masculine is up, and the first one for the feminine is down. So that's a binary, but it's also triadic. So there's a triadic generationality to it, but it's masculine and feminine quarks. The leptons, which is the other side of the elementary particles of the standard model, are the electrons and the neutrinos. And so there's electrons, and then there's muons, and then there's taus, and that's the triality of electrons. And then there's electron neutrinos, muon neutrinos, and tau neutrinos, which is the triality of neutrinos. And so the leptons are probably focus points, and they're points of discrete packets of information that are caused by the constraint of focus coming from our own minds when we make the observation. And whether it's a neutrino or an electron, it probably depends on the state that the universe is in when we make the observation. And so then you have the quarks, which we also just call elementary particles, but they're probably force points. They're points of force that are being enacted by the universe itself. They're like fingers being, manipulating information and applying force, which is really that fundamental force. Force fundamentally is animation. It's just action, the action by a sentient being in sentient singularity theory. It's the action, the enacting of will, the acting on will, I guess. So you can think of force points or quarks as like the fingers of God almost, or the fingers of the universe. And they're the first. That's why there's always, in a proton or a neutron, it's always like a proton is two up quarks and a down quark, and then a neutron is two down quarks and an up quark. It's like the left and right hand, where it's like two fingers and a thumb, two up quarks and a down quark, two down quarks and an up quark, and that just allows for it allows for information to start being processed in every way that it needs to, which is, like I said, it needs to be differentiated, it needs to be categorized, it needs to be prioritized. And you need this binary triadic symmetry structure in order to do that, because you need to be able to look at things in a binary and in a triality. The triality allows you to categorize, it allows you to observe causality, past, present, future, length, width, height. These are different ways of us. These are us organizing information into a triality. We do, and we observe this in quantum mechanics as well as in general relativity. When we see space-time, when we say space-time, it's four-dimensional. It's length, width, height, and time. Or it's XYZ and time, which is when you shift the perspective and you're looking at it kind of from the outside in. It's XYZ instead of, which is really like how far are you from the edge versus the exterior edge of the system, versus length with height, which is how far are you from a chosen point within the system. So we're this far, 6 feet this way from this point. We're 4 feet this way from this point, or it's 2 feet this way from this point. So it just depends. Are you picking the edges of the system and looking at it from the outside in, or are you looking, which is XYZ, or are you looking at it from the inside out, which is length with height? But when we're looking at time and we're actually processing how we can conceive of time and navigate time, which is how we should be thinking about it, we're thinking about past, present, and future. That doesn't mean navigating it is about going to the past or going to the future, or like in a kind of literal, nonsensical way, which is popularized by movies and books, but and now by physics, but or physicists, not by physics. But navigating the future is about navigating the constraints, the causal constraints of the present. What is going to be the inevitable or possible even result of me taking this action? Okay, well, if I, jump off of a cliff, what is going to be likely the effect of that? So that's how you navigate the future, is actually by conceiving of the future, imagining the future from the perspective of the present, given an awareness of the constraints of your current circumstances. And so navigating the past is about navigating the present, given your what's it called, hindsight perspective of your previous actions. And so that is navigating the past. It's like, I'm never going to do that again. It's not, oh, I'm going to go back in time and I'm going to, make it so that I never, did that stupid thing that I shouldn't have done. It's that, no, I'm never going to do that again. That's navigating the past, really. Like, that's how you are, that is how the closest you're going to get to navigating the past. That is what it actually means to navigate the past, is to apply, the constraints that you remember about the past to the present. And then how you navigate the future is by applying that, even your what you remember about the past, to and also what your current circumstances are in the present, and then applying that to what actions you take, so that you can choose what future you're in. You choose your future, not completely, but like partially. You do something. There's for action, cause and effect. That's what. It's just causality, guys. It's so I'm making this more complicated probably than it is, because again, I'm trying to put it into the context of these incoherent frameworks in us that we have. But like, the idea that you can go back in time and change something is not coherent. The idea that you can go to the future is not coherent. Anybody who believes in causality at all, which is everyone, cannot also believe in this and be logically coherent. Believe in time travel in the movie version of it, where you can actually just go to the past or the future. The issue with this is that it built into this assumption that, or even the question of can you go to the past or go to the future, is a framework that is defining the definition of time and future and past and present. These terms are defined by the context that you've put them in this circumstance. And it's literally a nonsense context. So you've created nonsense definitions. You're asking a hypothetical that doesn't make any sense, and you're assuming that the logic of this framework would make sense in asking the question, and it is completely destructive of your intuitive and correct definition and interpretation of time and present and future and past. Like the past, it's in the past. To quote Rafiki, it doesn't matter. It's in the past. It's like, but it still hurts. I know the entire every word in Lion King by heart because it was my daughter's favorite movie for the first 2 years of her life, and she watched it every day until I showed her the second one, which is still a solid movie, but it's nothing like the first. And then she would just switch off for like a year and a half. She'd watch Lion King, then she'd watch Lion King 2. Then she'd watch Lion King, then she'd watch Lion King 2. So I know every line. But Rafiki hits Simba in the head, and he's like, why did you do that? And he's like, doesn't matter, it's in the past. It's like, but it's still, Simba's like, but it still hurts. It's like, there's still an effect, but you can't really do anything about it. And at least not in the context of the past. You can't go back to the past to do something about it. You've just changed the definition of the past and the present and the future and time, and none of it makes sense. So it's really, the more you think about it, the more like astonishingly incoherent it actually is, and just how insane it is that we don't even realize how incoherent these questions are. And physicists talk about this stuff as if it's even a serious question, when they not even first starting with like or realizing that this is destroying of our definitions of these terms. And so I don't know. I don't think there's that much hope for like our current physicists, most of them, but the field, yes. I guess the field of metaphysics, and then emergently after that, the field of physics, I believe will make enormous progress actually in the next like 50 years. Probably, maybe even less, 30 years. Starting with sentient singularity theory. Probably, hopefully, maybe. But, like, what is an electron? Oh, it's this and this and this. No. Like when somebody says, I think string theory proposes that reality is actually made of really, tiny, tiny strings. It's like, strings of what? A string is not does not tell you like what something is. It tells you the structure of something, but something of anything. It's like strings of what? Strings of cheese, strings of spaghetti, strings of cotton, of wool, of information itself. What does that imply about the nature of existence? These are questions that are not asked. So, except by Alex O'Connor and me and a few others.
Yeah, I find it interesting. I've heard such a variety of views. not just on whether it's accessible to science, but what that fundamental stuff might be. You know, I have Brian Greene telling me it might be vibrating strings. I have Philip Goff telling me it might be consciousness itself. I have theists telling me that it's being and that all participates in God. And the one thing that I've realized is that the people who seem least confident in like having a view on what the thing is, the ontology, tend to be the scientists I speak to, because they think that explanation consists in like descriptions and models and mathematical predictions and stuff, like Sabine Hossenfelder did, or because they
Exactly. Bingo.
recognize that it's a question that's very difficult not to be a bit agnostic on. And it's like the philosophers who sort of have that kind of confidence. But at the very least, I agree with you that it should be a project for whoever you are.
Yeah, I think I would side.
I love that he said this. He's the first. Alex is the first person that I've heard say this, and other than myself so far, is that basically said that you can't. He said it's very hard to be agnostic about these questions, the answers to these questions, especially if it's you're calling yourself a physicist. It's you've dedicated a large amount of your efforts to quote unquote understanding existence or the universe or the world. And if you're going to do that, you have to understand two different kind of aspects of it that are simultaneously manifested always, but you can't look at both of them at the same time. We talked about that. Just like you can't look at heads and tails of a coin simultaneously, but a coin is always made of heads and tails, but you can only look at one side at once. Obviously that's a metaphor, but it's also true. Try it. But they're both, present always. And so when we're talking about the nature of existence itself, we have to talk about it in terms of its structure and its nature, not just its structure. It's not just saying it's strings. Strings of what? Not just saying it is matter, which is, I think, actually not properly understood. Matter is what matters by definition. It's matter is what matters. It is information that must be taken into account. It cannot be imagined away, things that you're just thinking, things in just your own mind. It's information that you have to contend with, and that means that it matters. It can't not matter. It must matter, and what must matter is matter. So that's not just like cute. It's like these terms have the definitions built into them already. That's why the terms exist. They wouldn't exist if they didn't have the definitions built into them. So I don't think that consciousness is mysterious or even matter is mysterious if you actually are looking at this properly. But if it's just this placeholder term to you for observation of something, and then that's not really something that is inanimate, usually assumed to be inanimate. That isn't really the initial definition. It might be relevant, but it's not the initial definition of matter. We say matter. Etymology. Etymology. Comes from materia. It really meant timber and woods and building materials. Derives from mater, meaning mother. Most users on Quora agree that this implies a tree trunk was viewed as the mother source from which all material or substances is derived. Yeah. See, this is, again, there's multiple definitions coming into play here that it shouldn't have branched off like this and just split, where physicists are using it one way and then everybody else is using it another way, like singularity. Materia, meaning timber or wood. Yeah, I mean, these building materials are always causal structures. They're things you have to contend with. That's what, when you're building, that's kind of built into the logic. I'm not just, you know, I guess, what would it be? It's like backwards justifying what I stated about matter being what matters. These symmetries in language are not always, they manifest downstream, even if they are not like part of the single strain of information that led to like the single term that is being referenced, because all words go through this causal chain of that constructs them. It's constructive causal chain. And when we're talking about matter and material, even if it's defined as like building materials, it's like it's constructive causal chain. That's what we're talking about. And information that is, especially information that has to be contended with, is kind of that which is constructive. That which is constructive causal chain has logical constraints to it. It's not just whatever you want. Oh, I'm just going to imagine that door to be red. That's white. It's like, no, it's white. And there are like, now we have to, in order to change it to red, we have to use the logic of, construction in order to do that. The reason why it's white is because it was made, our ability to even make it white is due to an understanding of constructive causality, or the causality built into construction, or intrinsic to construction, I guess. Can't build a house from the top down. I hope that makes some sense. I feel like that was not my best. But my point is that when everything is following the same rules, you will have symmetries that manifest even downstream, because it's still the same logic. So it leads to the same place. And language is language is based on symmetries. The foundation of sentient singularity theory is a linguistic symmetry structure, the fourfold linguistic symmetry structure of four primary perspectives that are inside, outside, separate, and oneness, that are all code-defining and code-generative and simultaneously understood. If I understand what is inside, then I understand what it would mean for it to be outside. And I also understand what it means for that to be that thing, and being one with itself, having this intrinsic oneness built into its thingness or even its being. And also that implies the understanding of what, is separate from it. So my cells are inside of me, and they are separate and one with me. And so in sentient singularity theories, primary perspectives, inside means separate and one, or having separateness and oneness. And then outside means separate from one, or separateness from oneness, instead of and oneness. It's from oneness. So outside is separate from one. Something that's outside of the house is not one with the house, but something that's inside of the house is kind of part of the house. It's like the bedroom. I said, my bedroom is one. An understanding of the bedroom is that it is one bedroom, and that it is also separate from the house. It's distinct. It's a distinct part of the house. So it's separate and one with the house, but because it's inside of the house. But if I said the shed is outside of the house, it's separate from the house. That should be pretty obviously or pretty intuitive. I don't want to say, I hate using the term simple, and I hate using the term complex or complicated, and because I don't think that I think it's just a feeling. Complication is whenever something is observed or perceived or experienced as complicated, it's really felt. It's just a feeling of overwhelm, of information overload. That's what it is. Versus when something is perceived as simple, it just means understandable. Like if something's understandable to you, then it's simple, or even immediately understandable to you. It would be simple. You would describe it as feeling simple. So, but okay, I definitely branched off a little bit. But what I was saying is, like, when I say this all the time, that there's no such thing as an atheist or an agnostic. And when I say that, I mean it very differently than everybody else means it. I don't mean it in Jordan Peterson's way of saying, well, if you believe in, if God is the most fundamental beauty and complete goodness, and you believe that in goodness and beauty, then you believe in God. And I like Jordan Peterson, but like that's not, no, you just change the definition of God to make sure that everybody believes in God. A friend of mine who's in our Discord server, who watches these streams, I have a Discord server if you want to join. It's a great community. Private message me on Instagram and I'll send you the link. But we have calls on there sometimes. We will have them again. But we would talk about the definition of God, and I had said that if you are looking for God and you can't find him, you should assume that your definition of God is incoherent or false, incorrect, because built into looking to or questioning whether or not God exists must be the assumption that he does exist, at least for the sake of argument. And so if you're assuming that he exists and you can't see him, and he is existence itself, that is like the definition of God. He's sentient existence itself, not just existence, but existence as a single sentient being that is the initial being and the all-encompassing being and the most powerful being. That being is God. Existence, capital E existence, is someone. That's someone is God. And so that's the inevitable definition of God. There is no other definitions of God. Any other definitions of God have any other use of the term God that isn't to refer to that being changes the definition of God. And so, but if that being exists, you're inside him. Just like your cells are inside you. If your cells are looking around for humans, they're never going to see a human. But they're inside of a human. So they're constantly seeing a human, but it's just not able to be seen completely in the way that they would have expected, based on how they are able to perceive pretty much every other being that is identifiable to them, which is a being that is capable of being next to them. Another cell. A white blood cell can look at a red blood cell and be like, that's someone. That's someone else. And they exist. But a white blood cell cannot look at a human, especially the human that it's within, because it's inside it. And so it's just the forest through the trees problem. And so given this definition of God, which is the inevitable definition, even if God, if existence fundamentally is not sentient, then God doesn't exist. But still, the definition must be what I just stated. Then you must assume that like certain things about this, that the way that if God exists everywhere and you can't see him anywhere that you look, it means like your definition is wrong. What you're looking for, what your expectation is incorrect. You have to assume that, and then you have to start thinking again about like whether you have the right a correct definition and that would allow you to actually make predictable assumptions. But this friend of mine in this Discord, he said, well, instead of saying that to people, I go the opposite way. And if I'm talking to them and I'm like, they say, I don't believe in God, I would say to them, but do you believe that, there is this character in a book called God? And they would say, yeah, of course. And then you'd be like, well, then you do believe in God at least, but it's just like, now let's go forward with that. But I don't think that makes that actually is a coherent way of going about this. I think that if you're going to make the assumption that if you're going to ask whether or not something exists, you are intrinsically assuming that it does exist. If you're actually honestly investigating in it or looking for it, and if you're doing that about the nature of fundamental existence, you're really asking, is existence sentient or not? And now you have to look for evidence of it. And so you can't be agnostic or about the nature of existence. That's saying I don't have an opinion about the nature of existence. You can't be an atheist, because to be an atheist means to lack an opinion about whether or not existence is sentient. You have no opinion on it. That's not possible. You engage with existence every day. You have an assumption about it. If you say, the universe really wants to, help you, you're a theist. Or you are pretty much a theist. Even if you don't have the same exact relationship with that being as I do, but you're still assuming sentient nature to existence. And if you're assuming that existence is not sentient, or that the universe is not sentient, then you are an anti-theist, not an atheist. The prefix of a means lacking. Like I've said before, my main passion is zoology. And in zoology, there's, albinism, like being albino. Everybody knows what albino means. Albino, really, it's amelanistic. It's like the technical term for it. And that means lacking melanin. Hypomelanistic means like less melanin, so lighter colored. Hypermelanistic means more melanin, so darker pigment. But an amelanistic animal is organism is an organism that lacks melanin. So atheist is someone who lacks a belief in a God, but you're not lacking. That's not a disbelief. It's a lacking of a belief. And so, what's his name? Oh my gosh. Sam Harris says this. He's like, I don't disbelieve in God. I have a lack of a belief in God. That's what an atheist is. When the New Atheism movement was getting popular, which I totally subscribe to from most of my from actually my entire life up until I was like 24. I definitely identified with the perspective of like the new atheists, like a Sam Harris type of perspective. Sam Harris, like 2013 Sam Harris perspective, but that's basically saying I have no opinion or no belief at all about whether or not existence is sentient or not, and that's impossible because you engage with existence every day. If you assume that it's inanimate and it's dispassionate, or not even dispassionate, but lacking any a will of its own, and just basically dead dust, then you are an anti-theist, not an atheist. And I called myself an atheist, but it's not a coherent term. It's actually an impossible term. If you look at what it actually means, it's impossible to have the belief, to hold the perspective that is described by the term atheism. Agnosticism is a term that can apply to many different topics, and it means like I don't have a strong belief either way on or opinion either way on a certain topic. And you could say I'm agnostic when it comes to God, and people do all the time, but you actually can't be, because that's basically the same thing as what atheism technically means, etymologically means. And you can't be that, but it's just a different term because, and I say this, and I think it is true. Somebody who says, I'm not an atheist, I'm an agnostic, is somebody who is really a theist who is in a room full of atheists or of anti-theists and doesn't want to admit that they're a theist, or they are an anti-theist in a room full of theists and don't want to admit that they're an anti-theist. They're just not being brave. That's what, and honest about their actual assumption. That's what somebody who calls themselves an agnostic is about God. You can be agnostic about aliens or Bigfoot or something like that, and that's fine because it's a specific topic, but God is not a specific topic. God is existence sentient, or is it not sentient? Are you inside of someone? Is the universe someone, or is it inside of someone? Doesn't matter either way, still the logic is the same. Or is the universe not someone, or existence it's not someone, it's just something. And if you think it's just something that's inanimate, that somehow is animated, that doesn't logically make sense, but whatever. Then you are an anti-theist, not an atheist, and not an agnostic. But so when to bring this full circle now, when Alex O'Connor says it's very hard to be agnostic about these topics, right here, it's actually impossible to be agnostic about these topics.
So whether it's accessible to science, but what that fundamental stuff might be. I have Brian Greene telling me it might be vibrating strings. I have Philip Goff telling me it might be consciousness itself. I have theists telling me that it's being and that it all participates in God. And the one thing that I've realized is that the people who seem least confident in like having a view on what the thing is, the ontology, I tend to be the scientists I speak to. Because either because they think that explanation consists in like descriptions and models and mathematical predictions and stuff, like Sabine Hossenfelder did, or because they recognize
that is not a difference in definition of explanation. Even that is a misunderstanding. That's just I used to be like that and not realize that about physics. I would be like, do you know that there's physics actually now seems to suggest that the universe is made of particles. It's made of it's actually made of strings, and there's actually 11 dimensions, not 4. I had no idea what a dimension was at that point, and I didn't realize it. I just was repeating what Michio Kaku and Sean Carroll and Stephen Hawking were saying in these Discovery Channel documentaries that I've watched. And I thought that I understood physics because I had memorized like the things that they were saying, which again, you can't even say that there's 11 dimensions if you believe in the 4D spacetime, because you would have to change the definition of dimension. I think I remember what's his name? Michio Kaku was like, some people think that these dimensions might be like curled up and very, very small, like these extra dimensions. It's like that is not size, has nothing to do with dimensions, not fundamental dimensions in the way that we use them in the 4D spacetime model. This is about degrees of freedom, to put it in how Eric Weinstein said it. I said before, the very first time I spoke to Eric, which I've only spoken to him a few times, but was on his Instagram, and I had a video of it up on the channel, and I was asking him about the definition of dimensions, and he did a good job explaining it. But even though I would expand on it a little bit, I would say it's a perspective of a constraint or degree of freedom. It's not just a degree of freedom. It's a perspective of a constraint or degree of freedom, which is kind of the line between those is really almost it's just determined by your goal. So walls are the constraint of a hallway, but there is no hallway without the walls. So they form the degree of freedom. The degree of freedom is formed by the constraint. So the path of being able to walk down the hallway, either this way or that way, is framed by the constraint of the walls. And so you are perceiving constraints and degrees of freedom simultaneously, always. You cannot perceive a degree of freedom without a constraint, and vice versa. But when Alex O'Connor is saying here, you can't be agnostic about these topics. You cannot be agnostic about the nature of fundamental existence. And the only possibilities, two different possibilities about that we could say about the nature of fundamental existence, not the structure, the nature, is it someone or is it something? Or you could say, is it someone and something, or is it something and not someone? It's the same end result, but those are really the only two linguistic paths that you can have, but they result in the same framing. Do you believe that existence is someone or not? Is it a being or is it just a thing? And if you think it's someone, you're a theist. If you think it's just something and not someone, you are an anti-theist. There's no other possible nature to include, or there's no other possibility to include as a possible nature of reality or nature of existence. Fundamentally, there isn't. Everything else, when he says here, Alex O'Connor, he's like, Brian Greene's telling me it's strings. Stephen Wolfram would be telling me it's computation. Other people are telling me that it's mathematics. Other people are telling me that it's particles. Other people are telling me it's consciousness. Other people are telling me it's strings. Other people are telling me it's being itself. Most of these are structures, not natures. Strings, particles, even, then you have processes like computation, which is just causal. It's just causality, in a technical context, in a technological context. I don't really understand how Stephen Wolfram's whole it's all computational. I don't understand why that, I don't understand the profoundness of that. It's just, you're basically just saying that there's causality. Okay, we know. Intuitively, everybody knows it. But we're going to talk about that next week. But there's really only two choices. Is it someone with will of its own and goals and feelings, or is it something that's dead dust, basically, in an inanimate structure? And when you frame it like that, and you start thinking about the logical implications of either of those, there's only one that makes any sense. The other one is completely incoherent. How does you can't simultaneously believe in evolution and also believe that existence is not sentient. I'm not saying people don't do that. I was like that, but the issue is that it's still incoherent. You're just not realizing it yet because you're not following the chain. You're just you've I guess compartmentalized these perspectives and never tried to connect them in a constructive way. As soon as you do, you will realize that it's incoherent. Something that is inanimate and lacking any will cannot somehow start moving. It's the prime mover argument is not just a philosophical topic of discussion in a high school or college class. It is actually something that you have to contend with and take seriously. But there is no such thing as an agnostic about God or about the nature of existence at all. And people that would call themselves agnostic or say that they don't have a belief about it, they're not sure, or not confident at all, that's not possible. They don't understand the definition of nature. Something's nature cannot be that it's a string. Something's nature cannot be that it's a particle. That's its structure. So, again, let's go to the 12 in F theory. I don't know what that means. Is that ChatGPT logo behind you? No, it's not ChatGPT logo behind me. This is a connectrica. I use it to show the issues with quantum mechanics and our observations. So imagine there's a structure like the universe, and imagine this is the universe, okay? And it's moving, it's animated, it's dynamic. At least let's say it's dynamic. Even if you don't want to say animated, it's dynamic. Obviously, it's dynamic because you are watching me and we move, and if we're moving, then the universe is dynamic. And if there's change occurring, the universe is dynamic. And so this cannot be the universe alone, just this. It has to be, you're looking at this thing that's moving, okay? And if I ask you, though, do you see the square? Yes, the square. But if I ask you, do you see the squares, multiple, plural? Yes. There's one, 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 and etc. And all within this one. It's an assembly of nested squares within this square, singular square. So if I asked you, is this a singular or is it an assembly? Like, it depends on both structures are perceivable. It just depends on which question you're asking. Are you looking for the assembly aspect of this structure, or are you looking at the singular aspect of this structure? Now, remember, it's still moving. If I ask you, do you see the wave? Yes, you see the wave. And if I ask you, do you see the helix right there? Boom, right there. Yes. So you actually can see that all of these structures are simultaneously present and constantly observable, but you can only pick one of them at a time. And so this is a particle. A square is a particle. The squares are particles, you could say. The wave is a wave. The movement of them that is causal, meaning like this one hits this one, then this one, then this one, then this one, then this one, and so it's a chain of movement, forms a wave, just like dominoes. Even it's just a series of multiplicity, and that is arranged into a causality chain. That's a wave of action within a string of dominoes is a wave. If you look at waves of water, it's a bunch of little particles of water, but it's also, there's water, like the whole assembly that you're looking at, and there's the ocean, and then there's the ocean is the water, is defined as the water, and it's made up of an assembly of a bunch of little particles, or multiplicity, not as an assembly, but a multiplicity of interacting particles of water, and they bump into each other, and that forms causal chains, which forms waves. And then there's also a helix, which is a structure that you see in fundamental information causal chains. That is not just causal, but it's also generative. It's like constructive and causal, which is generative. I use the term generative to mean causal and constructive. So it's like you're not just causing something to happen again and again and again. You're setting a chain off that grows. It's generative. It's a blockchain structure, and its DNA is a chemical blockchain, and it's a helix. Numbers are a quantitative blockchain, and they are also a helix. And all numbers are arranged into a symmetry structure that we can't even see, but it is inevitable. And you can see it in certain circumstances, but you can't just see it if you're counting. But if you arrange it into a like this, where is it? I can never find the spin sequence right here. As a constructive, like the Fibonacci sequence is a constructive causal chain, which is it's a generative information chain, basically. Generative blockchain of information. So it's the Lucas numbers, because they're building information on the previous. So the Fibonacci sequence starts with 1, and it adds it to itself, and then you get this, where every step is built on the previous. So it's not just causal, it's constructive. If you arrange them and you look at them from the right perspective, this is another constructive causal chain, but it's surrounded where the chain is surrounded by zeros because of a constraint in Excel. It allows us to see the helix. If I move this, you can see in the numbers, you will see a braid, a spiraling braid of strings of information, really, like where, basically arranged into a symmetry structure, which is, so when people say, oh, the double helix is the structure of DNA, no, it's not. It's the structure of generative information, and it just is the structure of generative information in a chemical context is DNA. That's what it is. And so the double helix is also the structure of any generative blockchain. It's not just DNA. So, and that includes like blockchain, for cryptocurrencies, and also not, just numbers, which is just a bunch of quantities that are arranged where they are the next a number is really a symmetry structure. So like 4 is a symmetry structure that's unique. 3 is a symmetry structure of singularities that is unique. 5 is a symmetry structure of singularities that is unique. And you can't construct the next symmetry structure without building it from the previous symmetry structure. Or previous symmetry structures in the chain. And so when you do this, you just form a bigger symmetry structure. And that's why you can see this braid of information. Like, you don't have to build that. It just is there. But it's really, it's just only in certain circumstances can you see that structure. And it's caused by information being self-referential. So when you see this is referencing this, and this 29 is referencing, the previous number. And this number also is referencing the previous numbers. It's just because it's constructive. It's just a number sequence, a constructive number sequence. And so you have 2 constructive number sequences, or generative number sequences, or generative information chains, or quantitative blockchains, generative quantitative blockchains, being woven together basically, and then you get this. So you have these two different strings that are kind of intertwining around each other, and that's why you literally can see it here. And the reason why it's a spiral is because those when information is referencing itself, it's physically, if you're going to think about it in a 2D way, it's chasing its own tail. It's constantly looping back to reference itself. And so if a dog was chasing its own tail as it was also growing, it would be like a spiral up. If you traced it, it would like do that. And so that's what's happening. And that's a metaphor, obviously, but like it still creates the shape in your mind, hopefully. Let me know in the chat. But that's actually super literally what is happening with these numbered sequences. And it's also like if you could view the blockchain that Bitcoin exists on, you would see this exact same structure. It's why that book, Gödel, Escher, Bach, In Eternal Golden Braid, it's a book about information. And it's like one of the most famous books in science. So Gödel, I have two of them actually over there. Escher, Bach. Gödel, Escher, Bach, An Eternal Golden Braid by Douglas Hofstadter. This is a book about the intellectual themes common to the lives and the works of the logician, Kurt Gödel, the artist, M.C. Escher, and the composer, Johann Sebastian Bach. It's interesting because Johann Bach is like a descendant of, or is related to Johann Sebastian Bach, and he's like one of the foremost thinkers on the nature of information and mind. And right now today, I think he's one of the few brilliant public thinkers about it. And so was, his ancestor. M.C. Escher, I interviewed Anton Baker, and I have never posted the interview because he asked me to make a video about the interview, not to post the interview, but I'm going to actually ask to just interview him. It's been years. This was back in 2020, and I still haven't posted a video about it just because life. And it was awkward to try and make a video about an interview that I did that I can't show. But now he's done other interviews with people. At the time he hadn't, so I think he'd be more comfortable with it. But I feel bad about never posting the video because he gave me, quite a bit of time on the phone. We had like a very long conversation, and he had no idea who I was, and I just reached out and I was like, "Can I talk to you?" And he was like, "Yeah, sure." But his mentor's mentor was M.C. Escher, and Anton Baker. You can look him up. He's a sculptor. Anton Baker. It's like, look at that. An eternal golden braid, basically, of strings of information that are intertwining. It almost looks like a double helix. Branching trees. But yeah, it's weird. I like can get way deep into it, like how inevitable that probably is. But I don't know if Kurt Gödel had any kids. Did he? I don't think so. He had a spouse. Yeah, it doesn't say any kids. Gödel developed an obsessive fear of being poisoned and ate only food prepared by his wife, Adel. I don't know if that's how you pronounce her name. Following Adel's admission to the hospital after suffering a stroke in late 1977, Gödel refused to eat in her absence. He weighed 65 pounds when he died of malnutrition and inanition. I've never heard that term. Caused by personality disturbance. What the heck is inanition? Severe deficiency in caloric intake. Starvation. It's starvation. Dang, 65 pounds? That's crazy. Like, that's less than half of what I weigh, and I'm short and thin. Kind of thin. Not as thin as I used to be. But the dad bod comes for everyone, especially if you become a dad. He was buried in Princeton. Dang. That's wild. I wonder why he thought he was going to be poisoned. Like, what did he think that he did? And who did he think was going to be poisoning him? I don't know. But, yeah, I bet you if he did have kids, they would somehow be relevant to, these topics. Yeah. Information that's generative is an eternal golden braid. Always. It's a double helix. This structure in sentient singularity theory is kind of a top-down view of the double helix. It's like if you're looking at the universe from a God's eye view, this would be it from the top down, and the double helix would be going straight through the center of it, connecting it all. And I don't mean the double helix just DNA. I mean like the chemical, informational, and tech, like I guess, and technological double helix, which they'll all connect. I mean, we've already, numbers are already connected to the double helix and to the blockchain of Bitcoin, but as soon as they start like connecting our DNA to the blockchain, you are linking fundamental strings of information, and that will happen. I mean, look at biometrics is already how everything is verified at this point. I used to scan my phone. First it was a password that I chose. Then it was my fingerprint. Now it's my eyes and my face, and then eventually it will be your DNA, and somehow it will link all of them, because just identity verification is going to just require you to be put into a blockchain, and the only way to put you into a blockchain is not to put you artificially into a blockchain. You can't do that. It's to recognize the blockchain that you're already in, which is your DNA. It's an information chain that is contextualized by preceding information chains, preceding blocks, and constructed out of them. So it's trackable, just like the benefits of blockchain financially. DNA has the same identity verification properties, I guess, that it can't be duplicated, it can't be faked when it's combined with other contexts. So yeah, it's inevitable that we connect these three things: numbers, DNA, and like monetary blockchain, or economic like blockchain. But this, when I say that this is a top-down view of the universe and that it actually is a double helix, just to prove, show you that I'm not like just saying that. Again, the double helix is a symmetry structure. It's a generative symmetry structure, and DNA consists of DNA double helix structure. If you look at like base pairs per turn and all this information, these 3 different components of it, repeating units, rotation per base pairs per turn, inclination to the axis. Like all of this stuff is, some of this is within the context of relativistic, metrics, I guess you could say, but others are like degrees to some degree. No pun intended, but some of them are just quantitatively like fixed. Like the number of base pairs per turn is like something that you can just count. It's not something that you have to create a kind of this artificial measurement model. But if you look at the symmetry, that is the symmetry structures, is this. It's like how many base pairs are present in a single rotation. And but if you look here, if you're like, this is the side view of each of these components, this is the top-down view. This, imagine all 3 of these kind of combined, that would be close to what this is. And I discovered that inevitably when I was just looking at models of entanglement of information in Excel, and I just tried to intertwine them as much as possible, and what you get is that structure. But here, symmetric set manifold. We go to like this, you will find in this structure the same, if you wanted to do like to measure how many cells form a square here, you can't actually form a single square that goes across from one side to the other. You'll get a 19 by 19 square that will not reach the other side. But then if you go to the other side and you do the same thing, you will basically get another 19 by 19 square. So it's like 2 19 by 19 squares overlapping each other. They have a bunch of other aspects of them, symmetries built into them. I'm doing a terrible job explaining this because I don't have the actually, they're on my website. I think I can look. If I go to models under my website, I think that I have some just symmetry models. This is kind of how I did this, by the way. I was just looking at like modeling a solid, a liquid, and a gas, and then I completely entangled it, and I got that. And but these are me exploring the symmetries of this. And so you can see there's a 4-fold center. There is no single point in the center. There's in this, from how this model, it's 4 cells that make up the center if you're actually going to get the center. And here, this shows it better. This is the center. There's no 1 in the center. It's just 4. That makes sense. And with physics. And then if you look at this green square, and then assume there's like a light blue square behind it. They're overlapping, but neither one reaches totally to the other side. So the blue square would stop here, and the green square stops here, just short of the other side. It's 2 19 by 19 squares overlapping. This is all consistent with the symmetries found in the double helix. And all their base pairs. So it basically is that. And so if you get this like sideways view of like the universe coming from another universe, it's basically this. One under the next, but it's really the one below here is actually inside of the previous one, but you can't model that in Excel in 2 dimensions, so I put it below. but it's kind of a sideways view. You get this helix, this intertwining, spinning, generative strings of information. And then if you look at it from the top down, you can also just kind of look at it from the center out. It's the same kind of thing. You'll still get the symmetry structures found in the double helix. It's fascinating. I'll do a whole stream about it. I don't have the exact models in front of me that allow me to show it kind of easily, but trust me, it's there. And I mean, you don't have to trust me. Trust me enough to watch another episode that I do about it. But if you don't trust me enough to do that, then you should just stop watching my channel entirely. I don't know why you're watching now, but shouldn't take my word for anything. But if you see truth in some of the things that I'm saying yourself, then that's why you should follow this channel. Hit the subscribe button. But yeah, even these are models of information change, basically quantifying the numbers of the number of information. You could even say the amount of information, the quantity of information in a that is required to change a matrix, the information in a matrix. So in a 4x4 matrix, to maintain coherence and change every bit of information in it, which is there's 16 bits of information, it takes 17 states and 16 actions, which adds up to 33. And in a 3x3 matrix, it takes 10 states and 9 actions, which is 19. And a 2x2 matrix, it takes 5 states and 4 actions, which is 9. And so this is to change information from the inside. To change it from the outside, it's always actually 4 states and 3 actions. It doesn't matter how big the matrix is. It's always the same. And I have a video on this on my channel that shows this right here. But these quantities are found in the double helix even. And it's because they are inevitable. It's just certain quantities occur in certain circumstances whenever you are changing information. And that's just the way that it inevitably is. So here, look at this. So this is an animation of that, like what I call a cosmological verse, which is like that rainbow colored pretty shape, one on top of the next. This is an animation of it generating and then replicating within itself, another one within itself. So here. Notice that it's like, when it zooms in on 4 because 4 is the center. All those numbers are not, they're not chosen by me. They are generated, given one single input, and then based on where the cell is, determines. So every time we zoom in, it's replicating another within itself, like a Matryoshka doll. And then that's a static image of it. But even that static model in Excel is not static, actually. All of these values, if I delete this single value right here, all of these turn to 0. If I add in 1 here, all of these generate because they're all building on previous existing information, depending on the position that's kind of constructed within the context of a certain relationship structure with those around it. And so context is information. So the place in the position of a cell here is the context of it, and that determines what equation is put into it, and then what cells exist around it is going to determine also the quantities within the cells around it is going to determine what the quantity is that's within it. You reach a constraint at the end, and replicates. This is, you know, it's not static. I didn't choose any of these. And you can only input one. Like if I change this to 2, yes, it changes all the values. Or, whoa, something broke. I change this to a 2. 4, something is broken. Huh. Something is broken in this one, but I'll figure it out later. I have multiple here. Here, let's just do this. This one should not be broken. Is this one broken? That one's also broken. Man. What is going on? I don't know. I got to figure that out. The models, there's an Excel cell that's busted. But the point is that if you can't put a 2 in to start, even though it would change, it does actually change all this values if it wasn't broken right now. But I have so many of these every like few months. It used to be, but now it's like every few years because I don't make changes to the models anymore. I just duplicate the Excel sheet that is document that has all my work on it, and then I just delete a bunch of unnecessary, you know, random models that I'm messing with that aren't part of, you know, something larger that I'm doing, and then build again because I end up with so many tabs. But the one thing that I will do soon is I'm going to upload an actual sheet of that model, of all these models, at least the 4 that are primary to sentient singularity theory, which was kind of 4 or 8, but not all of them are like constructive models or calculative models. They're just, you know, like the standard model is like a symmetry model, but there's no calculations going into like the model or the poster of it. So you don't, I need to post those on my website because they already exist if you go to models. But this one is calculative. I'll post an actual Excel sheet with the equations on it that people can download on my website. This one too, the quantum of concrescence, this is also generative. I will post that on my website that you can download and then mess with yourself. And then same thing with this, the cosmological verse. I will post that. But yeah. Here, let's go to one more really quick. That's the animation of that. And then if you go here, you go to this model. It says classical versus quantum computing, but it kind of is relevant, but it's also way more than that. This is those information, these, wait, where is it? Right here. These animated are is this. So you can pause and read through this. I wrote this years ago, so don't pay too much attention to the language, or but hopefully it makes some sense if you do decide to look at it. But, so we're going to try and change all this information to this, which is just, we're just changing it. Again, there's 2 degrees of freedom. There's either information or there isn't. And so, but I'm just showing that in terms of like 1s and 0s or reds and greens. But it just means differentiation. And we're changing from the inside out, so you have to maintain coherence. You can't change them all at once because you're not able to see the big picture from the inside. So this is how many steps it takes and how much information is actually 33. That's the number of information in a 4x4 matrix. In the change of information in a 4x4 matrix, the number is 33, or the quantity of information that is generated by the change. But if you're got a God's eye view and you're able to look at it from the outside then you can just do this. And it's the same. It's 3 actions and 4 perspectives every time. It doesn't matter if it's a 2x2 matrix, a 4x4 matrix, a 10x10 matrix. The value of information generated from the outside is always the same. It's 7 because it's 4 perspectives and 3 actions, and so 4 plus 3 is 7, which is interesting because it's, that's just an interesting number for so many reasons. Like if you divide in like, here's like an interesting thing. You should divide by 7, you get a repeating decimal point that contains like all the externally observable quantities in a given system. So here, I'll show you. That makes no sense. I realize that, but here, it actually does if you know what I'm thinking about. But here, hold on, I created it. So let's say we are right here. Like you take like, let's do 720 divided by 1, 720. 720 divided by 2 is 360. 720 divided by 3 is 240. 4 is 180. 144. 720 divided by 5 is 144. By 6 is 120. These are all like very, like, they're all very symmetrical, kind of even numbers. 120, 144, 180, 240, 360. But if you when you divide by 7, you get this infinitely repeating decimal, 102.85714, and it just goes on and on and on and on. 2857142. It's like almost all the other quantities from 1 to 9 are in there. It's 1 and 4 and 2 and 8 and 5 and 7. It's like, what are we missing? It's 1, 2, 3, 4, 5, 6, 7. And it's also 7 decimals. So it's like this is 7 and this is 7. 1, 2, 3, 4, 5, 6, 7. It's 7 different numbers, and then it repeats. And we're missing 3 and 6 and 9, which is also absolutely like fascinating that those are the 3 numbers that are not present inside of a 7, a division by 7. And it doesn't matter. So if like you go equals 3 divided by 7, again, same infinitely repeating decimals. You go equals 4 divided by 7. Same infinitely repeating decimals, equals 1 divided by 7. Same infinitely repeating decimals. As long as it's not a number that's divisible by 7, like 21 or 14 divided by 7, then you'll get 2. But if it's not divisible by 7 and it's 15 divided by 7, again, same infinitely repeating decimals. It's every single time. So these things are, when I say that there's inevitable symmetry structures, that are just like me, like seeing things that aren't there. That's just not that's just not true. It's that, you know, that doesn't mean everybody's interpretation of what these mean is correct. It just means like causality is constraining and leads to inevitable symmetries. Thoughts on AI being trained by scraped data on the internet, which has been through so many stages with lost in translation from ancient texts, which are already lostly converted from storytelling. I think that so in Islam, and it's like forbidden. People say it's forbidden to draw Muhammad. That's not true. It's forbidden to draw anyone in Islam. That includes animals. Anything that is a sentient being that is a known sentient being someone is forbidden in Islam to be made into an image, because it would be a distillation of what they are. Because you're talking about someone, and now you're just turned them into something, and that's not dynamic, and it's not operating under their own will anymore, and it's, you know, somebody else's will, so it's now a misrepresentation. And I never was like understood this until I saw deepfakes, and I was like, wow, that, you know, like deepfakes are really immoral, actually. Like, even though they're funny to make, you know, a deepfake video of, you know, the last 3 presidents sitting around a campfire talking about which Star Wars is the best. Like, that's one video, but it's also a representation of them that's not true, that didn't happen. And that's, you know, people also make much worse deepfakes about people that it's not so easy to spot whether or not it's true or not. And if you still have to know something about somebody to know whether or not it's to even have a chance at judging whether or not some deepfake is fake or not. But one thing, as somebody who has a background in zoology, if you see what people generate of animals, images of animals, it's like you do an image of a golden Philippine water monitor, which is like a very specific lizard. It is people won't realize that it's not an actual image of that animal, and unless you study them intensely, like I have, and then you're like, that is not a picture. That doesn't look right. There's something off about it. And the thing is that as you do this more and more and more, and more AI generated images of people and videos of people, and you know, images of animals are put online and are referenced by generative algorithms, like generative image algorithms specifically, you're going to get an increasingly corrupted version. And there's no way around it. It's just like you're feeding corrupted information back into the system. It's eating its own, like, shit. Like, that's what it's doing. And there isn't really a way to, like, avoid this, and it has implications and for everything. Even, you know, the output from language models, just, you know, giving you a summary of religious texts. It's like, it's not even going to be referencing the religious texts. It's going to be referencing commentary on commentary on commentary on commentary on commentary, and like, you know, out of context, because it's a machine. And then people are just going to trust it. And it's not good. So yeah, I mean, I think it's an amazing program. And it's funny because my wife she's a designer, and just like by everything that she's done, she's a photographer, she's a graphic designer, she's you know, got a great sense of, she's very good at interior design. She's just got a good sense of aesthetic, and she's always been very like anti AI because everybody was talking about how it's going to take the jobs of everyone, and it's looking more and more like it's not capable of doing that. It does make people more efficient, but it doesn't. It can, but it does not replace people. But it cannot replace the certain things that people can do. It doesn't have a sense of aesthetic, but she started using it the other day to design something like a room, and like just some design project that she was doing. She was using it really in depth for the first time, and she was actually like really, really good at it. And I was always telling her like, no, the best designers are going to be the ones who are the best at using these programs, and maybe you should just like try and use them. She was always against it, but as soon as she wanted to do something that she was like personally invested in and interested in, she used it, and turns out like she's super good at it. Like way better at it than me, and I have a really deep understanding of information, and but she has just a good sense of aesthetic, and it leads to me not being able to make good thumbnails, and her being able to make incredible designs for all kinds of things in like 3 hours worth of practice on ChatGPT. It's interesting. It's funny. Again, it's like anything that's aesthetic, whether it's music or anything like that, you're only good at it if you're not focused on how it's going to be perceived. You're focused on executing, like, and capturing it or creating the feeling that you're trying to create or to manifest. And if you're just focused on, do I look cool while I'm playing the guitar, you're going to be a shitty guitar player. I know that as somebody who practices the ukulele and is not a natural at first, but like, with my generation of visuals and design in Midjourney and ChatGPT and stuff, it's always been for thumbnails, which I'm like focused on how is this going to be perceived because it's a thumbnail. But then with her, it's like a personal design for a project she wants to do, and it's like it looks great. It's fascinating, but yeah. Here, let's go to next clips, and then we're going to call it in very soon.
Have consents, when the other one is something, the other one they consent, because their brains are quantum entangled. Mm-hmm. The fact is, these strange quantum phenomena and mechanisms are very much confined, almost always, to that subatomic realm. Mm-hmm. They are ephemeral, delicate features that disappear very quickly. We now, in modern terms, say the quantum effects decohere. The quantum weirdness, the being in two places at once business, dissipates like heat dissipating from a hot object when you put it in the freezer, very quickly once you scale up. So when you scale up to our everyday world, the idea that you can invoke quantum mechanics to describe telekinesis or telepathy or the nature of
the problem with this is, again, it's a language problem. When he says, as you scale up, if you understand what an electron actually is, that it's a point of focus that is caused by the constraint of your own mind in the context of you in relation to the someone that you're within, who is an animated being, and of the observation that you're making. If you combine all that and you understand what's the context of that is creating this observation, which is you're part of that context, the being that you're within is part of that context that is dynamic, and the constraint of information processing itself and the symmetry structures that are intrinsically involved, that are inevitable in that process, because again, you always start with one and you can only build from there, which means you can't skip to 5 from 2. You have to go to 3, then to 4, then to 5. That's what I'm talking about. That the constraint of causality in the context of quantity will always lead to certain structures and symmetry structures. That is all part of the context of that observation of an electron. And even the nature of fundamental existence itself, and an understanding of the definition of these terms, like an observation. People will be like, what is, we don't really know what an observer is. Does an observer have to be like a human or a sentient being, or can it be like a camera or a robot? And, you know, does it have to be conscious? It's like, observer is a term that has existed for a very long time, and we've never been like, what does it really mean? What is an observer? Can it be someone? Or can it be something that's not someone? We've never, ever asked these questions before, because they're incoherent with even the term observer, which is what the question should be built on, and it's not. And it's just great. It is like insane. Technically, I mean that as in like incoherent. But the thing is so he's saying, as you scale up, it's not about scale. It's about a shift in perspective and recognizing the difference in what is being perceived and the perspective that is being, you know, perceived when you're looking at an electron, or when you observe an electron, versus when you are looking at a cup or a water bottle. Like, you cannot separate this stuff from mind, from the structure / process of mind, which is the structure / process of you. Every someone is a mind. You have a brain, but you are a mind. I don't even know if saying you have a brain is the best way to put it, but it's not so linkable to back to a fundamental context. But in just a practical context, you can say I have a brain, but you are a mind. Everything that is built into and incorporated into your information processing, you know, in the actions of a pursuit of your goals becomes part of your mind. So if you have a calculator, it becomes part of it, and you use it, it's part of your mind. If you have a desk and you're writing on it, it becomes part of your mind. You have a notebook and you write in it, you write notes, you know, reference them, it's part of your mind. The room you're in, the tools you have access to, it all become incorporated into the mental structure that you are, which is, it's a mental structure / process. Mind is a structure / process. It's both. Yeah, all perception is dynamic. All thinking is especially it's active. It's like willfully dynamic, not just reactively dynamic. But all perception, all feeling is dynamic. You are moved every time you feel, every time you see, every time you feel emotion or physical sensation. It doesn't matter. It's all metaphysically it is generative of a dynamic metaphysical system or informational structure. And that's why when you feel something, you say, that moved me. You know, I was really impacted by that song that Bach wrote. You know, it's like you say things like that because metaphorically, intuitively, it hits. But yeah, it's not about scale. Human beings follow certain quantum mechanical processes. Like, you know, when I've said this before, and I think I have it actually. Once somebody on this physics Discord that I was very hostile, you know, way back when I first unveiled these models before it was even called sentient singularity theory, they were like, no, they thought they were just very hostile to the idea that a proton or a neutron could be a sentient being, or that a molecule could even be a sentient being. And they were like, nobody thinks that a proton is a sentient being. And I was like, I think a proton might be a sentient being. And this guy he has a PhD in physics. He was like, there's no way for that to be true. If that were true, then nothing would be predictable. And he was like, they don't make choices. And I was like, they do make choices. They just, you just don't realize that they're making choices. And he was like, they don't make choices. If they made choices, they wouldn't be predictable. Nothing would be predictable. Chemistry wouldn't be predictable. Nothing like that. And I was like, well, you make choices and you're still predictable. And he didn't really have like an argument against that, but it's true. We can make choices, at least. I'm not saying we all do always make choices. Most of the choices you make throughout the day are not actually choices. Anything motivated purely by instinct is not choice. And choices are usually very specific and usually within a moral context, because it involves like sometimes choosing a goal that is against your instincts. And a choice is free will, freedom of will, which is your actual ability to make choices, is in your ability to choose your own goals. And usually that's only occurs in a circumstance where it's possible for there to be a mismatch between what you want and what you should do, or what your instincts are motivating you to do versus what you should actually do. Those are moral situations usually. So most of our true choices are almost always moral choices of choosing your own goals based on moral perspective, the context of morality. Outside of that, you don't really make choices. It's like, am I going to choose to take the scenic route, or am I going to choose to take the quickest route on the way to the grocery store? Whichever one you choose is not actually a choice. It's just dependent. It's just the inevitable, most likely the inevitable outcome based on a multiplicity of factors that you don't actually have control over, which is like, how much time do you have? And, what is your current emotional state? And are you hungrier than you are, happy? If you are, then you're going to take the quickest route. But if you are happier than you are hungry, then maybe you will take the scenic route. If you don't have very much time and you have to get back by, within an hour for a meeting, then you're going to take the quickest route. And it's like, none of these are choices. They're like, they're just actions based on constraints that we have that we didn't choose. But you choose your goals. That's what freedom of will is. It's not the ability to choose whether or not you want something salty or sweet. It's the ability to, and when you and what you eat, whether or not, if you pick a salty snack or a sweet snack, it's like, it's always motivated by your instincts and your cravings. It's not motivated by a choice. It's like, I really want something sweet, but I'm going to choose to eat something salty just as an exercise of free will. It's like, no, nobody does that ever. I've never done that. Neither have you. Maybe now you could, but I don't even think it's an honest choice. It's like you're doing something else at this point that has nothing to do with food. And it's probably motivated by some emotion to try and like prove something to yourself. But yeah, our true choices are usually moral, and they're just in choosing your own goals. They're not even necessarily in always choosing your actions in the moment, but they are in choosing the trajectory of your actions over time. And but you are very predictable. But the thing is that here's the thing, is that it has to, if you knew always exactly what was the right thing to do, and you always knew every consequence that would have happened from every choice that you would have made, good and bad, you would be very predictable probably in which choice you made. And so if you have enough information that is relevant, or even if you have, let's say you have all the relevant information to move forward in a choice, then, making a specific choice, your choice would be probably almost 100% predictable. So the fact that we can basically predict, how atoms, will bond with each other to make certain molecules, and how certain molecules will interact with each other to make certain chemical reactions, is not evidence that our prediction ability is not evidence that of a lack of choice. It could be also evidence of that they have enough information to make consistent choices that are, there's not really outliers. And I think that this is the case. I think that in this periodicity of sentience and sentient singularity theory, every time you go, which is this right here, hadron, atom, molecule, cell, organism, family, caste, technological singularity, and then it replicates within itself. Every time you stack the next level, it basically results in a wisdom explosion for the assembly below. So an organism, becoming an organism, a bunch of single cells unifying and into an assembly, and then having someone stacked on top of that assembly, which would be like an organism, multicellular organism, or an animal, results in a wisdom explosion for all the cells below that make up the assembly, because of the addition of kind of a holistic perspective that is provided by the organism. That doesn't mean that there aren't instances in which cells lack wisdom, but they're rare. And when they do happen, they usually result in like cancer, metastatic activity. So it's when a cell doesn't realize that it's part of the whole anymore, and that it starts to try and like live forever or maximize its own glory, or because it doesn't realize that to do so is to destroy the container that it actually requires in order to survive in the first place, which is the being. But the thing is that if you, as a human with a body made of cells, were aware of all of your cells, the state of all your cells at once, you would immediately, as soon as you saw one going metastatic, you would, if you had an ability to change that, which Michael Levin is working on, by trying to communicate with a cell via electrical signals to reorient it and get it, like, feed it information that changes its perspective and gets it to stop being cancerous, you would do that. And that if you couldn't do that, you would kill it, because you know that it can't actually achieve its goals. Even if it can't perceive that from inside, you know that if you let it continue, it's going to kill you, which is going to kill it. So nobody's continuing to be constructively generative if that happens. We have to end it in order for you to go on. And it has to not kill you in order for it to continue. It's for its impact, its meaning to be maximized, its impact to continue. So it tries to maximize its meaning, but doesn't realize that it's doing it at the sacrifice of the someone that it's within, and that's not actually possible. That's why God's will be done, because he just won't. There will be a limit where he just won't let you continue. If you're gonna whatever you're doing is going to actually stop his plans. Just like if you were aware that one of your cells was turning into cancer, maybe you like try and talk to it at first with some electrical signals, coming from Michael Levin's work. But if it doesn't respond, it's like you're going to end it, because you can't allow it to continue. Your will be done in this circumstance. So the fact that there's a stacked perspective that gets a God's eye view kind of all of the assembly of that is contained within it adds a wisdom explosion, because I'm aware that, you know, you can't, if my cells go cancerous, it doesn't give them, they can't achieve what they're seeking. But they don't know that because they don't have my perspective. So that's a wisdom explosion. So basically, every time there's a wisdom explosion, it makes the previous layer much more predictable, because there's more, they have relevant information contained within it, and anything that doesn't doesn't work with within this generative assembly is going to just be eliminated somehow. But so protons and neutrons, even if they are sentient beings, their actions would be more predictable than molecules that would be sentient beings, and their actions would be more predictable than cells that would be sentient beings, and then organisms that would be sentient beings would be, more predictable than the next level up. And but here's that repeating 7 again. You can see starting with 720 because that's the number of cells here. In that, this is, look, a hadron is an assembly of quarks, an atom is an assembly of hadrons, a molecule is an assembly of atoms, a cell is an assembly of molecules, an organism is an assembly of cells. You go to this consecutive cosmological verse, an atom is orange, coincides with orange, an assembly of hadrons. A molecule is yellow, go to yellow over here, an assembly of atoms. An organism, blue here, is an assembly of cells. And these are the layers of evolution in sentient singularity theory. So moving from here to here is adaptation. This would be, you go to a cell, be like this one type of bacteria to this type of bacteria to this type of bacteria. Versus if you go to an organism, this layer, this would be a fish, this would be a frog maybe, and this would be like a mouse, and this would be like a gorilla, and this would be a human being over here or something like that. But every time you jump between layers from here to here, you complete this layer, you start constructing the layer on top, you're stacking. So an organism is stacked on top of an assembly of cells, which is stacked on top. A single cell is stacked on top of an assembly of molecules. A single molecule is stacked on top of an assembly of atoms, etc. So there's replication, which is this way, which is adaptation across generations, and then there's stacking, which is ascension, basically. So there's replication and stacking, or adaptation and ascension. Ascension or stacking is between the levels in the periodicity, and adaptation or replication is across a level in this model. But yeah, see, you need this like holistic context to have any kind of hope of unifying any of this stuff. But we're gonna look at one more thing, and then we're going to call it, which is time.
Strange that each of those 3 big pillars of physics.
I just noticed my wife said in the chat a bit ago, I still don't like generative AI, but she is good at it. She doesn't, I'm not saying she has to that she likes it or not, like that. That's up to her. I mean, it's not even up to her. It's just like how she feels, but she is good at it. That's what I'll say. I was impressed.
Describes time in a different way. So quantum mechanics, like Newtonian mechanics, in fact, classical mechanics that we learn at school, regards time simply as a label, as a parameter. It's called coordinate time. So it's basically, here's an equation that describes how something changes. I can work out what its state is at a particular moment. Then if I change that t in the equation, t for time, to some other value, I can crank the handle and work out what that system's doing at that later time or at an earlier time. That's all time is. It's just a parameter that goes into an equation. General relativity says, no, time isn't just a number. Time is a dimension. It's part of the fabric of four-dimensional space-time. It's a real thing. In fact, it's, all times coexist. And then thermodynamics says, no, time isn't a dimension. It's not a number. It's an arrow. It's a direction pointing from past to future in the direction of increasing so-called entropy. So I think until we reconcile these very, very different pictures of physical time, we're not going to be able to reconcile those theories themselves together. I think time may not be the central thing that needs to be solved and to get it, but I think it's part of that question. Until we understand these disparate, different ways of describing time, we're not going to come up with a theory of everything.
Yeah, I mean, time sort of looms over everything. You can always forget that it's there for something like when you're talking about.
There is only one way to unify all of these different conceptions or definitions of time. It's in the context of sentience and any other conceptions or definitions of time. So, like I said earlier, we're using the same term in many different circumstances, and that is not something that we should really be doing. I don't think. Time, we have to pick a definition, or not even pick a definition. We can just look and see what it is. Time, etymology, term time, origin, and original meaning. Old English, tema, or temporal duration, limited space of time, from Proto-Germanic time, or time, constructed from pi, daimon, suffix formed root da, to divide. So Swedish time, an hour. So like an hour divide, to divide. An abstract sense of time as an indefinite continuous duration is recorded from late 14C, personified as an aged bald man, but with a forelock, carrying a scythe and an hourglass. Okay, there's a lot of symbolism there, but I mean, it's personified. Time, if you want to understand any kind of change, you must personify it within the context of a person, of someone, God, being that we are within, that is taking action and moving, is dynamic and active, and like his will be done again. He's working towards something, and like we can all get on board or not, and whether or not we do that is going to impact, whether or not we're part of the generativity of meaning and of being, and of meaning, which are the same things, or they're not the same things, but meaning is maximized as multiplicity of being is maximized, and so and the impact between them but is maximized, but so, or you can get on board or get left behind, basically, which is entropy. People are always like focused on entropy in physics, and entropy is just change, and obviously that's true, but it's like the universe is always, it's not just, entropy is not the constant in the universe. There's two constants, you could say, of change. It's like there's entropy and there's generativity, but really, like, entropy is just kind of the perception of entropy, or perspective of an entropic perspective, is just due to the generativity of the cosmos. It's if things are growing and towards something and evolving towards something, then that requires a recycling of information and a referencing of information that's already exists always. And so you can't just keep some information static forever and then change this over here. It's all connected. Just like on my universe model or my cosmological verse model, you enter in a 1 and it changes everything. But they're all connected, even if they're kind of branching into different trees, and you can change this one. It doesn't seem to change this one, but the fact that it all recoheres eventually means that there is any change is ultimately relevant. Any information is ultimately relevant to all other information. Because the universe must be entirely self-referential, or existence must be entirely self-referential. So all information must be reconciled to maintain coherence with itself. There's no ability for anything to be separate outside of existence and still exist. So again, this constraint causes us to perceive entropy when we're not looking at what is actually the point. You're like, oh man, that molecule is decaying and away. It's like, but look over there. Human beings have been constructed and have evolved from protons and neutrons. that is not entropy. But to do that requires holistic information change, and that means that if you're not looking at what is growing, you are just going to look at something that is being kind of used and reabsorbed by that which is growing, and then but if you're not focused on that part, and you're just like, oh man, that molecule is decaying, and it's like, well, but it's going to be reincorporated into ultimately what is the point of all of this, that is the willfully motivated generation of multiplicity of sentience. So I don't like focusing on the focus on entropy, other than just in a engineering kind of practical way. It's not actually consistent with the goals of God. It's just a byproduct. So that matters. It's like if you're just there's entropy, it's like, but what about evolution? Is evolution, if entropy is how we define time, is just change in the context of entropy, but shouldn't it be the context of change instead of just entropy alone? Why wouldn't we also factor in evolution into this? Because that's also change. And evolution it's not just biological. Obviously it's not just biological. Anybody that just confines it to biology is just assuming a definition that isn't actually coherent with the context of the cosmos, of what is actually going on. It's just you got a definition from your teacher at school and you're just sticking with it. No, evolution, no matter how you define it, is a process that precedes the existence of cells, of biological cells, and continues even beyond or multicellular organisms. But yeah, English, a single word encompasses time as extent and point, as well as hour. So time after time is moment after moment. Time warp, time traveling, is a science fiction sense of the time machine. H.G. Wells. This is all written in this Etymon line website. Time of day. These are different things. So we have a feeling of time. It's the experience of the passing of time, which is really the feeling that we have as we navigate the change around us, the cycles of change around us. And then we have, the definition of time is just change in relationship structures, like, entropy, but also evolution. And this is like what this definition of time is similar to like assembly time, which is like Sarah Walker and Lee Cronin's assembly theory describes time as the number of steps taken in the construction of increasingly, I don't want to say complex, they would say complex structures, but just the change that beings go through. And so not just beings, but it is just beings, but they don't realize that it's just beings probably. But there's assembly time. That's like what he's saying, includes entropy and also evolution. But physicists don't think about that because they're constrained to just thermodynamics and things like that. They're not thinking about change beyond the field of physics. And then you have time as like a dimension, which is like length, width, height, time. And we're going to talk about that in a minute. The general relativity context of time, which is that it is kind of a constraint that just frames the structure that space is, the material space is kind of like arranged in at any given moment. And then you have the feeling of time, and the feeling of time is really like an interesting thing because, when it's in sentient singularity theory it unites and kind of gives context to all of these different definitions, or you could pick of time. Not that you could pick, but that people use for time. And one of them is when it's change, whether it's evolution or entropy. That's just because there are beings that have wills of their own that are not your will, and they are dynamic too, and they're moving even if you're not. If you stand still, they're going to keep on going, and you're going to be left behind. You're going to perceive entropy around you. You can also align yourself with and work with them, and you'll perceive evolution and growth. But that's time in that kind of like assembly time type of perspective. In sentient singularity theory, it's just the will, the being acted on by all the other beings around you and within you, and that you are within. And then time in general relativity is this as a fourth dimension. It's this right here. So this is a motility or manifold, I call it right now. I don't know if that's I think this is Eric Weinstein's Observerse, but it might not be, but it's very relevant if it's not. But so if every sentient being's mental structure starts with the four primary perspectives, these self-referential, simultaneously generated, four perspectives that allow us to orient in relationships beyond relativity. So not just bigger than, smaller than, faster than, slower than, brighter than, dimmer than. It's like there's no scales here. It's just, but there's still multiplicity in relationships. So something can be outside versus inside, separate versus one, and they're all co-defining. Outside means separate from oneness. Inside means separate and oneness. But if you look at this, imagine this is a four-dimensional mind, and then this is another four-dimensional mind inside of this four-dimensional mind. So this is a cell inside of an animal, or it's you inside of God. Doesn't matter. Or you inside the universe. they're both sentient beings that are four-dimensional, most fundamentally four-dimensional minds, orient within by the perception of four primary perspectives, basically. And so they're overlapping because one is nested within the other. I can't model that in Excel because it's two-dimensional, so I put it below. And you have three perspectives of each one overlapping with three perspectives of the other. So you have an objective or sovereign constraint, a negative degree of freedom, which is moving away from your goal. You have a subjective or relativistic constraint, and then you have a positive degree of freedom, which is towards your goal. And same thing here. Negative degree of freedom and a positive degree of freedom, a subjective constraint and an objective constraint. And imagine you are inside the universe. The universe is moving, and so are you. And it is perceiving and navigating via four primary perspectives, primarily, and so are you. And you have to navigate their actions. They have to navigate your actions, basically. And so you also have to think about, if you're a cell inside of a human, the human is space, and its movement is and it's the process that the human is going through is time, in a way. It's like greater. It's a big component of time. It's a big component of the change that it is subject to. And so here you have the current location. If you're a cell inside of a human, your current location is your relativistic constraint. You can choose it, but you don't choose it. You are intrinsically always in your in your current location, because by definition your current location is always your current location, because by definition if you change your location, you still are going to be in your current location. So it's a subjective constraint. You can't escape it, because you're subject. It's a constraint that's subjective to you. It's a subjective perspective that you cannot escape. Then you have this subject. It overlaps with a subjective perspective of the being that you're within, which is the present moment, and which is the state of all information in the system, like a snapshot of it. Versus the current location is, where are you in this relation, this information kind of chain of information. So and it's like this, the present moment is the sum that is perceived by the being, I guess you could say the higher being is the sum of all the current locations of all the interior beings that make up the assembly that is the body of the being that is the stacked being. And so then you have a positive degree of freedom and a positive degree of freedom. So a positive degree of freedom is a future moment. It's a future state of oneself. If you're a human, it's like the future state of your body is also going to change the location, and be dependent upon the location also as well of a cell within the body. So new location is a positive degree of freedom for a cell inside the body. Future moment is just the sum of all the new, of like the future locations of all the cells within the body. And in the past moment, again, same exact thing, previous location. It's just away from your goal. That's what defines it as the past or previous. It's moving away from your actual goal, whereas future is moving towards it. Present is you're always in the present. The subjective constraint. You're always in the present moment, and you're always in your current location. Positive degree of freedom is to move towards your future moment, to move towards your new location if you're inside. Your negative degree of freedom is to move away from back to your past moment, which is away from your goal, and back to your previous location. So you could, if you're hungry and you want to go to Chick-fil-A, but like, I don't know, you just realize you don't have money on the way there, you have to go backwards to your previous location back home. But it's away from your goal of Chick-fil-A. So you have 3 times here: past moment, present moment, future moment. These are 3 times, that the exterior being kind of like is perceiving, but it's really a state of its own being. But you would perceive it as times from the outside looking in, or from the inside looking out. But from the outside looking in, you would just see it as states of your body, basically. But your objective or sovereign constraint is space here, because you are space to this being. Okay? And whereas time here is the objective or sovereign constraint, because the directionality and change of time, or changes over time, are the changes made by the beings, the actions of beings beyond you. So like you are, it's beyond your constraint. It's a constraint that exists beyond you, basically. Whereas this is a constraint that's caused by you. This is a constraint that's caused beyond you. That has a cause beyond you. In this one, it's a little bit tricky because it's not really beyond you, because you are space, but it's the definite, like it's still logically beyond you. You can't really escape it. And it's not caused by like your actions, like your present moment is determined by your actions. But this is not. You are constrained to being you, which is constraining, which it forms the space that of the beings that are within you. I am the space time to my cells. Okay, but they so basically we have space time, which is when you are inside of a being and you're looking out, like when your cells are looking at the human that they're within, or whether or not when we look out at the universe that we are within, we see space time. We can navigate the space, length, width, height. But these 3 perspectives kind of like cause that viewpoint, but that's when you're applying a metric to it in that circumstance. So it's not actually fundamental. It's interesting because Eric Weinstein says this. He says in his model of geometric unity, there's a 4-dimensional structure that is like the proto space-time. It's like space-time, those 4 dimensions, length, width, height, time, are not actually fundamental in geometric unity, if I understand correctly. That makes sense with sentient singularity theory as well. Inside, outside, separate, and oneness are what form 4 perspectives that would be experienced as and navigated as past moment, present moment, a future moment, and space. Or you could just say objective constraint, subjective constraint, positive degree of freedom, and negative degree of freedom. But then that, in this nested relationship structure of a being within another being, causes this being to perceive what we call the 4 dimensions of space-time, which is length, width, height, and time, which is really length. It's like length, width, and height here, which is a navigation of space. New location, current location, present location, previous location. This is more fundamental than the relativity of space-time, of the space-time dimensions, because this is about is contextualized by a goal, and length, width, height, and time are not. But time here is something you're just subject to. Space here is something that this being is just subject to, because it is space. It can't really escape it. And so from the outside looking in, you have time space, basically. And from the inside looking out, you perceive what we call space-time. So this is what causes this relationship of nested beings that are subject to each other, or in some way informationally bound to each other, causes the perspective of causes the interior beings looking out at the being that they're within to perceive what the dimensions that we call space-time. That's what it is. Length, width, height, and time. That's where the 4 dimensions of space-time come from, right there. And I hope I made some sense. Please comment in the chat and let me know. I'm getting tired, so I recognize it in my struggle to explain this. But that, I'm just showing you, there is an explanation in the context of sentient singularity theory for the observation of the 4 dimensions of space-time. And for the observation of entropy and evolution. And then there's also the feeling of time, though, that is this other aspect of time, which is that, dependent upon, it's just our experience and how we contextualize certain and divide certain memories and compare them to others. So basically, when you're really young, if a summer or a year of your life, and if you're like 8, a year of your life feels like a really long time because it's 1/8 of your life, and it's really like 1/6 of the life that you remember, because you don't start forming memories. You don't start being able to form memories that are accessible later on in life at will until you have really started to be proficient in complex language, because that allows you to basically label the files of memories. But if before you can speak, you can't label those files with anything other than certain senses, like that's why smells trigger certain feelings that are like grandma's house when I was so young, but I don't like remember exactly anything else about it. It's like because you don't have labels for even the structures around you, like doors and cars and kitchen. You don't know what a kitchen is at 1.5. So you can't be like, if somebody's like, do you remember when you were in the kitchen when you were like 1 year old? You didn't know what a kitchen was then, so you couldn't label the memory with kitchen. It's not that the memory isn't there, it's just that it's not as specifically framed, and it's also not accessible by language. Like somebody have to make you smell the same smell that you smelled when you were in the kitchen, and then maybe it brings back the feeling that you felt when you were in that circumstance, but that's about it. You're not going to remember the coffee cup was over there because you don't know what a coffee cup is, so you're not looking at that thing as a specific thing. But when you get older, like you're my age, I'm 35. Oh my gosh, I'm 35 years old. A year is like that. And why? Because you're not comparing this year to last year when you're thinking about it. You are comparing this past year to all the other, to the rest of your life prior. And it's 1/35 of your life. So it feels like it's much, much faster because it is. But the thing is that every day doesn't go by faster because you are comparing the today to yesterday, not today to all the other days prior, because going to sleep and waking up segments it in a fundamental, gives you a fundamental segmentation of experience because you're going to sleep and then waking up. But if you don't do that, you have a hard time with keeping track of time and things like that, because you or of events. You have a hard time keeping track of of events because you don't have the context, like the natural intrinsic context of this segmentation of your kind of like coherent experience by sleep. So your days will never feel faster or slower than they always have, because you're always going to compare it to the previous day. Maybe you'll be like, this day went by faster than yesterday, but like you won't be like every day gets faster and faster. It's like what makes them go by faster or slower is dependent upon what you're doing that day, but not by how many days you've experienced. Whereas a year, because it's kind of objective, or like a more just, it's more it's not fundamentally defined, as fundamentally defined as like a day, which is defined really by waking up and going to sleep, not by like 24 hours. It's defined fundamentally by you going to sleep and then waking up. That's a day, and to your mind. And but yeah, so that's why years go by faster every year, but days stay relatively consistent. It doesn't, or at least how fast they go by is not dependent upon your age. So like this is that's sentient singularity theory's context, allowing for the interpretation of these observations and experiences that we have. And they seem to make sense. Let me know in the chat if any of those things make sense. Even like why you need sleep. I had an epiphany after I came up with these after I deduced these models of like why sleep is even necessary. It's like because for the same reason that you need a day you can't be at work all the time. If you're working all the time and you're always on call and you never get like time off or a break, you can't like focus on creating order in your space, because you're constantly focused on creating order according to the goal that's coming from your boss. So you're not like you're not prioritizing eating, giving yourself sustenance, taking care of yourselves, cleaning up your own house. So eventually your house just gets messier and messier and messier, and you don't eat properly and sleep or anything like that. And basically it's a buildup of disorder. Whereas when you go to sleep, you're actually like letting your cells off the clock, where they can now clean up their space and take care of themselves, because they're not focused on making your will be done. But if I go and I reach for this water bottle, every single cell in my body, in my arm, has to be like, okay, time to go. We all have to move. But if I'm asleep, they don't have to worry about that. They can actually kind of be free to go and do the things that they need to do to set themselves up to be productive again for me when I need them. But if you don't give them that, it's just like if your boss never gave you any time off. You would never clean your house. You wouldn't eat properly, and you'd lose willpower even, because none of your like own personal goals would be able to be sought. And that's exactly what you experience with yourselves when you don't sleep for an extended period of time, or when you do sleep, you see your body seems to like go back to order, whereas like if you don't sleep, your body functions aren't working as properly, your face starts to change. But then you go to sleep, you wake up, your eyes look brighter, your face looks more put together, different color, maybe a little bit less gray. And when you move, like you move with more authority, versus like if you're exhausted and you haven't slept for days, like your movements just feel less motivated. It's not because your motivation is down necessarily. It's also your cells are just like, what am I even doing? All I do is work all day. I don't get to do anything for me. What's the point of even working? They just get demotivated. So you have to let them off the clock. Like, they're a separate being. If they weren't, then it would be just like a machine. Just keep it oiled. But it's not. Your body is an assembly of sentient beings that have their own wills and lives, and they need to be able to go and pursue those. as well. So anyways, sleep is natural housekeeping. Yeah, it's natural housekeeping. All of these are very like intuitively, they intuitively fall out. Here, like they're talking about the past, and in this other clip, they're talking about, does the past or future actually exist? Such a ridiculous question. Like you've changed the definition of past and future, and you're assuming this like nonsensical fairy tale, not even fairy tale, like fake like context, like H.G. Wells' time machine is not real. Okay, last clips, and we're going.
Okay, more question for you, which is this. Could time be an emergent property of the universe? And if so, what does that mean? What is an emergent property?
It's possible, yes, and I think a number of people working in the foundations of physics are starting to talk in that language. Emergence is a quite a complicated thing to describe. The simplest way of describing emergence is, well, for example, consciousness is an emergent property. You know, it emerges once the neuronal connections in the brain become complex enough, and the system become complex enough. A much simpler example.
Temperature be another example?
Temperature.
What an insane assumption to make. Consciousness is an example of emergence. Consciousness emerges when the connections in the brain become sufficiently complicated or complex or whatever. Like there's so many false assumptions built into that, definitions being used. Like when people are like, I study complexity. We're going to talk about this next week, but Stephen Wolfram, he talks about this and a lot, and he's like, and he's brilliant. He's got his moments of brilliance for sure. But when he's like, you know, what really amazed me is a bunch of simple rules over time in the context of multiplicity of, you know, actors will eventually result in complex, you know, complexity. And it's like, the heck is complexity, man? Like, what the heck is simple? Like, it's just, those are feelings that you have when you look at information, and whether, just depending on whether or not you're overwhelmed or not. But there's no, like, when people are like, I study complexity theory, like, what the heck is complexity theory? Complexity theory is an interdisciplinary scientific framework that studies how massive webs of interacting decentralized parts simultaneously produce unpredictable, disorganized, and organized behavior. Rather than look, it's not, I mean, I just hate the term. Rather than looking at parts in isolation, it focuses on emergence. The whole becomes greater than the sum of its parts. Dude, I'm not going to get into it.
Temperature itself doesn't exist when you get down to the molecular level.
We'll get into it next week.
Molecules zoom out, and you get something called temperature. The wetness of water is another one. Sure. You'll never appreciate wetness of water.
So, for instance, though, when he says, you know, consciousness emerges when there's a bunch of, you know, there's enough like connections in the brain. What about like C. elegans worms? It's like double-digit number of cells. There's no brain in the way that we, you know, in that looks anything like ours. And what about cells? Just a single cell. If you zoom in close enough on a single cell, like it looks just like an animal. It's like behaves like an animal. It's a pretty. It seems to act like a being, in every way. And you know, you can't see the sentience of anyone else other than yourself, and you can't not see your own sentience. But you know, we can take best guesses. You know, if you obviously assume your dog is someone, you assume your spouse is someone, you assume your friend is someone, you probably assume I am someone, and but you don't know. But you assume. I assume cells are someone. If you look at them, they act just like, there's no difference. If you zoom in close enough, it looks just like any other organism. It moves towards certain things and pursues certain things and acts certain ways in certain circumstances. And but if that's the case, then like it's sentient, you know, but it doesn't have a brain in the way that we, you know, in the way he's thinking about it. So did it require like a sufficient amount of like connections in the brain? And it's just ridiculous to make that assumption so confidently. Consciousness is actually emergent. It's in the brain. I bet if you could do a brain transplant with someone, you wouldn't swap. You wouldn't change bodies. You would just change like mental talents. But you wouldn't. It'd be like getting a new heart that was stronger than your old one or something, or a new arm that was stronger than your old one. But it wouldn't be like swapping bodies. It'd be like your brain is a computer, but it's not the container of consciousness or of sentience. That seems pretty obvious when you look at cells and very, you know, like low quantity multicellular organisms as well. But emergence is like, yeah, I guess like the wetness of water. Sure. But I think that's more definitional. Like, it's like, you know, water isn't, if you saw one molecule of water, you wouldn't be like, that's water. Be like, that's an H2O molecule. You could say that's a water molecule, but you wouldn't say that's water. Because there's something about water that it has to be like many molecules, and just in how the word came to be is that it describes a fluid, a specific fluid, not just a molecule, a certain molecule. So again, like, I don't even know, I don't really like the term emergence. I don't think it has any causative explanatory power. It's just observational. It's like observationally descriptive. It's like something seemed to emerge from that. This seemed to come from there, but like it doesn't say how. But like it's assumed by many people in physics and stuff to contain also like the how. Like he just said, once there's a sufficient number of connections in the brain, then consciousness emerges. It's like there's a causative aspect to it, instead of just an observational element. I don't agree with that. I hate the term when people use the term emergent. Is time emergent? What does that even mean? Time, which definition of time are you using? And emerging from what? I don't know. It's perceived.
How much you study a single molecule of H2O? You need trillions of them together for that property to emerge.
The sponginess of a cake, perhaps, you know.
Yeah.
None of the ingredients or the atoms themselves are spongy. But
Exactly.
put them together and zoom out and you get sponginess.
Exactly. So the idea is that time itself doesn't exist at a fundamental level.
Even then, it's like a cake is the context that we're talking about here, though, not like the ingredients of the cake. It's like no ingredients are spongy, but then the cake is spongy. Yeah, the cake is just spongy. Like, that's just a description of the cake. Like, you know, it's not a description of the ingredients. I don't know. I think that we are confusing. We are very confused. Context is information. And like, definitions don't just change, and words wouldn't exist if they didn't already have determined definitions built into the term itself. Okay, last clip. There is a link below to a video that I made on an old one about time, and that model that I showed you of the overlapping thing. And I talk about like metaphors of like why time seems to flow by you, and but I don't have time to get into it. But you should watch it. It's short and it's not a live video. It's one of my few like pre-produced videos. But it is, just be mindful that the language is my word choices were made, in 2020 when I made that. It's been years.
Relativity and quantum mechanics, because I've heard it discussed in some contexts that, and like I said, I'm not a physicist, so I might be wrong about this, but one of the problems might be the way that they both sort of deal with time. Quantum mechanics might require instantaneous, like, the present is real and it's the only thing that exists, whereas relativity has this time block, this time traveling. If time is emergent, maybe it's just that like the quantum world acts at a small enough level that time hasn't emerged yet, and so it makes sense to say that, well, time functions this way on the quantum level, but once you're talking about general relativity, you're big enough that you have this emergent quality of time, which is a property of space-time. And I sort of wondered if having time as an emergent property at some higher level of complexity of atoms might help us to solve part of the problem as to why the big doesn't mesh with the small.
Yeah, maybe. I mean, that would suggest that quantum mechanics is a deeper level of reality,
right?
Where time has a more fundamental, or there's some fundamental feature of the quantum world that isn't the time that we perceive, and that general relativity and how it sees time as part of 4D spacetime is emergent from a deeper quantum level. It may be. I'm not sure. I mean, all the research into finding a theory of quantum gravity, a theory of everything, there's still the debate. Do we start from quantum mechanics, or more correctly, quantum field theory, and do we move towards general relativity, or do we? So that's what string theorists would say. Or do we start from general relativity? The space-time is fundamental, and we quantize it. That's what people working in loop quantum gravity.
Yes.
So do you start from this end and move towards that end, or that, or do you start from both and meet in the middle, or do you scrap them all together and come up with something new? I mean, that's where
you have to do what he just, his last explanation. You have to start from as fundamental as you possibly can, and which is, just ask yourself, what is the first question? The answer is, what is the first question? That is actually the first question you can ask. Then you ask yourself, what is the second question, which is, what is the truest thing that I know, basically. I guess maybe the second question would be, what is the second question? The answer to that would be, what is the truest thing that I know? And then the answer to that would be, I am. And then there's probably a next question, but I haven't thought about it enough. And then you also have to, like start thinking about the logic of existence by the definition of existence itself, and that it is singular because it is all inclusive, and there is nothing beyond it because anything outside of existence would be non-existence, and non-existence doesn't exist. So you can kind of approach it to these two different ways, and they do meet perfectly. They arrive at the same conclusion, and then you build from there, and you see if your models naturally lead to quantum mechanics, the standard model, or general relativity. But you don't start with general relativity or quantum mechanics and try and put them together, or you start from the beginning. You're looking for not a way to unify to connect quantum mechanics and general relativity. You're looking for the context that is fundamental to both of them. And you don't get there by going backwards. You can only go forwards, which means you have to scrap them all and start from the very beginning. I have a video called Theories of Everything How-To Guide. It's the first video that pops up if you're new to this channel on my channel. And it was the prize-winning video on Curt Jaimungal's Pace 1 competition. And it basically starts with that. It's like, you're not trying to get a more fundamental theory by building on less fundamental theories. You can't do that. You have to start from scratch and then just see if what you naturally get lines up with what we can observe. And that's what you do.
We really are with finding a theory of everything, that we don't know what our starting point is, that we can say, well, let's start from here. We know this is a correct description of reality. Let's figure out how to get to the other end.
Yeah. Oh man, that's amazing. It's like, I feel like I'm sort of auditing physics, because everybody keeps hearing about this theory of everything. It's like, someone's told you they're going to build a grand palace or a new hotel or something, and you come in and you speak to the builder and it's like, okay, how's it going? How are we getting on? And they're like, hate to tell you this, we haven't even agreed on how to start yet.
We haven't done the foundations.
We'll get there eventually, I'm sure. And in part that will be thanks to people like you and works like yours. Forthcoming, it will be.
Yeah, I mean, I disagree with that last part. I don't think that it'll be because of work like Jim's, but I'm not trying to be cruel. I really appreciate him being honest in this conversation with Alex, and it takes some humility to do that, and that's the most important quality in a scientist, in really anyone. And I appreciate that they had this conversation and had it publicly, even though I think it highlights that physics is failing its audit. And there's only a few people that are actually good at auditing it. And it's become trendy to be like, physics is failing. It's failed. And it's true. But it's like, that doesn't, shouting it enough times isn't enough. You have to actually like propose an alternative perspective that may actually be buildable and generative. And that's what sentient singularity theory is. That's my proposal. It's a metaphysics framework. And it's not a physics theory in and of itself, but it is the context of our physics theories. And even beyond. But I think Alex is doing a great job auditing physics, and I really am entertained by seeing just how honest he's able to get these people, because he's actually asking the right questions. Most of the time they're just like, what is, an electron? Is it a wave? Is it a particle? Is it, what is it? And then they, physicist says something that everybody's heard, and then we just accept it and move on. Whereas Alex is like, yeah, it's you're describing a negatively charged particle that, has these properties. That isn't actually a description of what it is. It's a description of what we're perceiving it doing. And that's true. Asking the right questions is the most important thing. And understanding yourself and the being that we are all within and subject to is also a matter of asking the right questions. So anyways, with that, thank you, everyone. Just like a good song needs the breaks, not monotone. Yeah, exactly. With that, I will go, and I will please hit the like button, subscribe, comment any parts that you think would make good clips below. I'm terrible about that, making clips, but I want to get better at it. But I need your help. Anything, any moment that you were like, this would make a good clip, just timestamp it and put it in the comments. I'd really appreciate it. But